Now we are going to discuss another question. See the question here. The output of a circular convolution performed on two signals is. What is the output of a circular convolution which is performed on the two signals? So x1 of n, they are given which is 2, 1, 2, 1, and x2 of n which is 1, 2, 3, 4. So basically in this question they are saying that they are given the two discrete time signals and they want to find what is the overall circular convolution of these two signals that they want. What is the circular convolution of these two signals they want? So the four options, option B is the correct solution of this question, which is 14, 16, 14, 16 is the correct solution of this question. So let's solve this numerical. So in the question what they are given, x1 of n they are given which is 2, 1, 2, 1, and x2 of n also they are given which is 1, 2, 3, 4. What is the circular convolution of the x1 of n and x2 of n? So what is the representation? Circle with a dot. Circle with a dot is called as circular convolution. But if you want normal convolution means this is a symbol. Circular convolution means this is a symbol. So this is a symbol you have to keep in your mind. So this is a normal convolution and this is a circular convolution. So this is a representation always you have to keep in your mind. So we can say this is a normal convolution and this is a circular convolution symbol. So x1 of n, circular convolution of x2 of n we need to figure out. So how to do this one? So this circular convolution is also going to satisfy the cumulative property. We can do in the reverse process also. So first I will take x1 of n. So what are the elements? 2, 1, 2, 1. Then I will write 2 from here. Then 2, 1, 2, 1. Then from here 2, 1, 2, 1. Then 2, 1, 2, 1. Means every element we have to move by 1 unit. We have to move by 1 unit. So here 2, 1, 2, 1. Then from here 2, 1, 2, 1. From here 2, 1, 2, 1. Next 2, 1, 2, 1. This is x1 of n. Then what is x2 of n? Take the elements 1, 2, 3, 4. So 1, 2, 3, 4. So now do the matrix multiplication. Then what you are going to get? 2 into 1 is 2. Plus 1 into 2 is 2. Plus 2 into 3 is 6. 1 into 4 is 4. So 2 plus 2 plus 6 plus 4. 10. 1 1 is 1. Plus 2 2 is 4. Plus 1 3 is 3. Plus 2 4 is 8. So 1 plus 4 plus 3 plus 8. Then 2 into 1 is 2. Plus 1 into 2 is 2. Plus 2 into 3 is 6. Plus 1 into 4 is 4. Again do the addition. Then 1 into 1 is 1. Plus 2 into 2 is 4. Plus 1 into 3 is 3. Plus 2 into 4 is 8. So do the addition. So if we add all these things, then we are going to get finally 14, 16, 14, 16. So this is basically a matrix multiplication, a row and a column, row and a column, row and a column, row and a column. So the final solution that we are going to get, which is 14, 16, 14, 16 is the circular convolution. So let me do the reverse process also. So this is x1 of n circular convolution of x2 of n. But what I will do in the reverse fashion. x2 of n circular convolution of x1 of n. So here I have to write circle here. I have not written. So let me write. So this is the circular convolution. So first I need to take the x2 of n elements. What are the x2 of elements? 1, 2, 3, 4. So 1, 2, 3, 4. Again from here. 1, 2, 3, 4. Again from here. 1, 2, 3, 4. Again from here. 1, 2, 3, 4. Then what is x1 of n elements? x1 of n is nothing but 2, 1, 2, 1. So 2, 1, 2, 1. So do the matrix multiplication. 1, 2 are 2 plus 2, 1, 2 1 into 1 is 2 plus 3 into 2 is 6 plus 4 into 1 is 4. So we are going to get here 2 plus 2 plus 6 plus 4, which is nothing but 14. Similarly, 4 into 2 is 8 plus 1 into 1 is 1 plus 3 into 2 is 4 plus 3 into 1 is 3. So if we do the addition, we are going to get 8 plus 1 plus 4 plus 3, which is nothing but 16. Similarly, 3 into 2 is 6 plus 4 into 1 is 4 plus 1 into 2 is 2 plus 2 into 1 is 2. So if we do addition, what we are going to get 6 plus 4 plus 2 plus 2. Then 2 into 2 is 4 plus 3 into 1 is 3 plus 4 into 2 is 8 plus 1 into 1 is 1. So if we do addition, what we are going to get 4 plus 3 plus 8 plus 1. So if we have the corresponding elements, then what we are going to get finally 14, 16, 14, 16. It is same in both the cases. So you can do either the same process or the reverse process, and you are going to get the same solution. So this is basically matrix multiplication. Whereas normal convolution means we have to do in the tabular format. But this is a circular convolution, so you have to move the unit by move the every the first matrix, move the every number by one unit, and then you are going to get some matrix, and you have to multiply with the another matrix, then you are going to get the solution. So these things always you have to keep in your mind. So normal convolution means we can do the by the Taylor method or the convolution by the standard procedure. But this subtle convolution we can do by this matrix method. So by this matrix method we can get the subtle convolution output in a very easier manner. So these things, so you have to always keep in your mind. So if x1 of n subtle convolution of x2 of n means first x1 of elements you have to write in the matrix format. So move the every number by one unit. Then you are going to get certain matrix and multiply with the another matrix of the elements which are present in x2 of n. And if you do the matrix multiplication, we are going to get the result. So x1 of n circular convolution of x2 of n is equal to x2 of n circular convolution of x1 of n. So in both the cases, we are going to get the same result. So this part always you have to keep in your mind. So now let's go for the another question. See the question here. The question says that consider the analog signal x of t is equal to 3 into cos of 100 pi t. If the signal is sampled at 200 Hz, the discrete time signal obtained will be, listen carefully, consider the analog signal x of t is equal to 3 into cos of 100 pi t. If the signal is sampled at 200 Hz, then the discrete time signal obtained will be. So basically what they have given some analog signal x of t, and also they are going to sample this analog signal by 200 Hz. Because the sampling frequency is 200 Hz. And what is the discrete time signal obtained expression that we really want? Means, suppose if you take an analog signal and if you are going to sample, then definitely what you are going to get sampling is with the help of impulse train. If you are going to sample this to the multiplication of these two signals, and what we are going to get a digital signal or a discrete time signal that we are going to get. A discrete time signal that we are going to get. So what is the expression of that we need to figure out. So the four options, option B, which is 3 into cos of pi into n by 2 is the correct solution of this question. So let's solve this numerical. So what is the equation they have given? Analog signal x of t which is equal to 3 into cos of 100 pi t they have given. So this is the analog signal they have given. Then what is the sampling? The signal we are going to sample by impulse train. Impulse train we are going to sample. So if you are going to basically what is the sampling frequency they have given? 200 Hz. Sampling frequency is 200 Hz. Then what is the sampling time period, which is inverse of the sampling frequency, which is 1 by 200. And I have already told you, basically, if x of t, this is the expression. So at each and every time ts only, we are going to get the corresponding discrete time signal. So at each and every ts, like 0 ts, like 1 ts, like 2 ts, like 3 ts, similarly minus ts, minus 2 ts, only at these instance only, we are going to get the values. So replace t by nts. So wherever t is there, replace t by nts. So x of nts is equal to 3 into cos of 100 pi into nts. So basically we are going to replace t by nts if we want to convert the analog signal to the discrete time signal nts. That's it. So we are going to replace t by nts. So then what we are going to get? X of nts is equal to 3 into cos of 100 pi into nts. N is nothing but integer values. It can be 0, it can be plus or minus 1, plus or minus 2. So n is equal to integers. So n is equal to integers. Let me write here. So let me write the integers. Then what is ts here? Ts is equal to 1 by 200. So 1 by 200. So 0, 0, 0, 0 cancels. We are going to get pi n by 2. So finally 3 into cos of pi n by 2. So this is the discrete time signal that we are going to get. So this is a very, very simple thing. Just what we have did. We have replaced the t by nts. Then we are going to convert the analog signal to the discrete time signal. So if you are going to replace the t by nts, and ts is nothing but 1 by fs, the substitute values will be simplified. So we are going to get the expression of the discrete time signal, which is nothing but 3 into cos of pi n by 2. So this is the correct solution of this question. So now we are going to solve another question. See the question here. Which of the following system is linear? So which of the following system is the linear system that we need to figure out? So basically in this question they are given 4 options, 4 systems, and out of this system is the linear system that we need to figure out. So option A, y of n is equal to e to the power of x of n. Option B, y of n is equal to a into x of n plus b, and option C, y of n is equal to x of n square. and option D, y of n is equal to s square of n. So what are the four options? Option C is the correct solution of this question. So option C is the only linear system, whereas option A, option B, and option D are the non-linear systems. So let us discuss each and everything in a very detailed manner. So now we are going to discuss the solution regarding this question in a very detailed manner. So what is the first system they have given, which is y of n is equal to e to the power of xn they have given. So y of n is equal to e to the power of xn they have given. So for the system, the input is x of n and the output is nothing but y of n. So therefore, for the system, the input is x of n and the output is y of n. So what is the expression of the output and input, which is y of n is equal to e to the power of x of n. So now, for the system, if the input is x1 of n, then what is the output? y1 of n is equal to e to the power of x1 of n. For the same system, if the input is x2 of n, then what is the output? y2 of n is equal to e to the power of x2 of n. For the same system, if the input is x3 of n, then what is the output? y3 of n is equal to e to the power of x3 of n. Suppose if this new input is a summation of the two previous inputs, then what is the corresponding output that I want to figure out? So if x3 of n is the summation of the two previous inputs, then what is the output that I am going to get? Let us see. So if x3 of n is equal to x1 of n plus x2 of n, then what is the expression of the output y3 of n I want to figure out? So y3 of n is nothing but e to the power of x3 of n. So in place of x3 of n, I have substituted x1 of n plus x2 of n. Then I am going to get e to the power of x1 of n plus x2 of n. Then I want to see what is the summation of the two previous outputs, which is y1 of n plus y2 of n. So with the summation of these two outputs, then what we are going to get e to the power of x1 of n plus e to the power of x2 of n. As the new input is summation of the two previous inputs, but the new output is not the summation of two previous outputs. So the given system is said to be non-linear system. So therefore, as y3 of n is not equal to y1 of n plus y2 of n, so therefore the given system is said to be non-linear. See, whenever the new input is summation of the two previous inputs, and if the new output is summation of the two previous outputs, then only we can say the given system is said to be linear system. Otherwise, it is said to be a non-linear system. So therefore, we can say the system A, which is nothing but it is a non-linear system. So let's go for the system B. So what they have given, y of n is equal to a into x of n plus b. So definitely what I can say here, nothing but here the input and output relation of the system is nothing but input is x of n and output is y of n, which is y of n is equal to a into x of n plus b. So for the system, suppose if the input is x1 of n, then what is the output that I am going to get? y1 of n is equal to a into x1 of n plus b. For the same system, if the input is x2 of n, then what is the output that I am going to get? y2 of n is equal to a into x2 of n plus b. For the same system, if the input is x3 of n, then what is the output I am going to get, which is y3 of n is equal to a into x3 of n plus b. Suppose if this new input is summation of the two previous inputs, then I want to see what is the corresponding output I want to see. So if x3 of n is equal to x1 of n plus x2 of n, then the output y3 of n, what it will be? It is nothing but a into x3 of n plus b. So in place of x3 of n, I am going to substitute x1 of n plus x2 of n. Then you are going to get y3 of n is equal to a into x1 of n plus x2 of n plus b. Okay? Then I want to see what is the summation of the two previous outputs I want to see, which is y1 of n plus y2 of n. So y1 of n plus y2 of n, if we add these two things, what you are going to get? A into x1 of n plus x2 of n plus b is nothing but 2b that we are going to get. And you see clearly, this y3 of n is not equal to summation of the two previous outputs, which is y3 of n is not equal to y1 of n plus y2 of n. So therefore we can say the given system is said to be non-linear system. So even if the present input is summation of the two previous inputs, but the present output is not the summation of the two previous outputs, so therefore we can say the given system is said to be a non-linear system. So this point you have to keep in your mind. Similarly, let's go for the system C and let us see whether it is linear or non-linear. So now, what is the system C? Y of n is equal to x of n square, they are given. So for the system, the input is x of n, and what is the output? Output is y of n is equal to x of n square. So let us discuss more about this one. So for the system, the input is x1 of n. What is the output that I am going to get? y1 of n is equal to x1 of n square. For the same system, if the input is x2 of n, what is the output I am going to get? y2 of n is equal to x2 of n square. Similarly, for the same system, if the input is x3 of n, what is the output I am going to get? y3 of n is equal to x3 of n square. Suppose if the new input is summation of the two previous inputs, then what is the new output that I am going to get? Which is, if x3 of n is equal to x1 of n plus x2 of n, then what is y3 of n that I am going to get? See, y3 of n is equal to x3 of n square. See, already you know x3 of n is equal to x1 of n plus x2 of n square. Then what is x3 of n square? Wherever n is there, represent by n square. then what you are going to get? Y3 of n is equal to x1 of n square plus x2 of n square. Then what is that? Summation with two previous outputs. If y1 of n plus y2 of n is nothing but x1 of n square plus x2 of n square. As you see clearly, y3 of n is equal to y1 of n plus y2 of n. So therefore, we can say the given system is said to be linear system. So if the input is the summation of two previous inputs, then the output is also the summation of the two previous outputs. So therefore, we can say the given system is said to be a linear system. So in your question, they are asking which system is the linear system. So option C is the correct solution of this question. Now let's go for the system D here. Let's go for the system D. Then I've already told you here, system D is nothing but y of n is equal to x of n whole square. So now suppose let's see whether the given system is linear or not. Let us see. For the system, if the input is x1 of n, then what is the output? y1 of n is equal to x1 of n whole square. For the same system, if the input is x2 of n, then what is the output I am going to get? y2 of n is equal to x2 of n whole square. For the same system, if the input is x3 of n, then I am going to get the output as y3 of n is equal to x3 of n whole square. Suppose if the new input is summation of two previous inputs, then I want to see what is the output I am going to get. So if x3 of n is equal to x1 of n plus x2 of n, then what is the output that I am going to get? Let us see now here. So y3 of n is equal to x3 of n whole square. And you know, x3 of n is nothing but x1 of n plus x2 of n is substitute here. So y3 of n is equal to x1 of n plus x2 of n whole square. And I want to see what is summation of the two previous outputs I want to see, which is y1 of n plus y2 of n, which is nothing but x1 of n whole square plus x2 of n whole square. As you can see clearly, the y3 of n is not equal to y1 of n plus y2 of n. So therefore, the given system is said to be nonlinear system. Even though if the input is summation of the two previous inputs, but the output is not summation of the two previous outputs. So therefore, we can say the given system is said to be a non-linear system. So what is the meaning of a linear system? The linear system means it must satisfy both the homogeneity principle as well as superposition principle. Then only we can say the given system is said to be linear system. Means if the input is summation of two previous inputs, then the output should be also equal to summation of two previous outputs. Then only we can say the given system is said to be linear system. Otherwise, it is said to be a non-linear system. So therefore, we can say finally, out of the four options, option C is the correct solution of this question. So we can solve this question in a shortcut method also, which is, if you see option A, there is exponential. Exponential means by default we can say it is a non-linear system. In the option B, then you can see a constant. Whenever you see a constant, then what is the meaning of this one? We can see that this is also, whenever you see any constant, then default we can say the given system is said to be non-linear. In the option D, we can do a square operator. Square is nothing but non-linear operator. Square, cube, all those into power, all these are non-linear operator. So by this also we are going to get a non-linear system. So this point always you have to keep in mind. And I have already told you, for a linear system, if the input is 0, then the output should also equal to 0. Remember, because the given system is said to be linear. Shortcut, remember. If the input is equal to 0, then the output should be also equal to 0. Then only we can say the given system is said to be linear system. Because I have already told you, for a linear system, if the input is x of t, then output is y of t. Suppose if the input is a into x of t, then output is also equal to a into y of t. Means if the input is multiplied by some scalar quantity, then output is also multiplied by the same amount of scalar quantity. Suppose if a is equal to 0, then input is equal to 0. So therefore the output is also equal to 0. So if the input is equal to 0 means output should be equal to 0 for a linear system. So if substitute input is equal to 0, then output here is going to get 1. So it is not equal, it is not equal to 0. So we can say this said to be non-linear system. Similarly, it is not equal to 0, so we can say it's a non-linear system. Here also, even the input is equal to 0, but output is not equal to 0. So therefore, we can say this is also non-linear system. So by these things, we can eliminate this one and this one. Here there is a square operator, cube operator, nth operator, all these are the non-linear operators. So because of this, again, the system is non-linear. So this is the correct solution of this question. So I want you to remember only one thing, which is whenever the input is equal to 0, the output should be always equal to 0 for a linear system. Otherwise, it will be a non-linear system. So whenever the input is equal to 0, the output should be always equal to 0 for a linear system. This point always you have to keep in your mind. Okay. So option C is the correct solution of this question. So now let's go for the another question, which is a signal m of t is equal to 3 into cos of 6000 pi t plus 4 into cos of 7000 pi t plus 5 into cos of 10,000 pi t to be sampled. What is the minimum sampling rate for band pass sampling for truthful representation? Listen carefully. A signal m of t is equal to 3 into cos of 6000 pi t plus 4 into cos of 7005 t plus 5 into cos of 10,000 pi t to be sampled. What is the minimum sampling rate for band pass sampling for truthful representation? So basically they are given some analog signal. And what is the minimum sampling frequency? Sampling rate means what is the minimum sampling frequency that we need to figure out in order to get back the original signal from the samples. So listen carefully. What is the minimum sampling frequency in order to bring back the original signal from its samples? That is what they are asking this question. So out of the 4 options, option D is the correct solution of this question. Is 10,000 hertz is the correct solution of this question. So let's solve this numerical. So what is the signal? Analog signal they have given m of t is equal to 3 into cos of 6000 pi t plus 4 into cos of 7000 pi t plus 5 into cos of 10,000 pi t. So this is the signal they have given. So for the signal, what is the minimum sampling frequency in order to get back the original signal from the samples we need to figure out. So we have 3 terms, right? So we have 3 terms. First term, second term, and third term. So let us try to find what is the frequency of each and every signal. So this is a cos omega t. Omega 1 I am going to construct, which is omega 1 is equal to 6000 pi. Omega 1 is nothing but 2 pi f1 is equal to 6000 pi. So pi cancels, and if we simplify, f1 we are going to get 3000 hertz. Similar second term, cos omega t means omega 2 I am going to assume. So omega 2 is equal to 7000 pi. So omega 2 is equal to 7000 pi. Omega 2 is nothing but 2 pi f2 is equal to 7000 pi. Pi cancels, and if we simplify, f2 is nothing but 3500 hertz. Similarly, the third term is also cos omega t. So omega is nothing but omega 3 I am going to assume. So omega 3 is equal to 10,000 pi. Omega 3 is nothing but 2 pi f3, which is equal to 10,000 pi. So pi cancels, and if we simplify, f3 we are going to get 5000 hertz. So now, first term frequency is 3000 hertz, second term frequency is 3500 hertz, and the third term frequency is 5000 hertz. See, whenever you are going to add the signals, then what is the maximum frequency means? See, basically, I've already told you. See, if you are going to in the time domain and the frequency domain. In the time domain, whenever you are going to add or subtract, same thing is going to happen in the frequency domain also. And if you want to find what is the maximum frequency present in something, that simply maximum of all the frequencies. So try to out of all the frequencies, it is the maximum frequency that is called as the f-max. So in the time domain, if you are doing addition or the subtraction, same thing is also going to occur in the frequency domain also. And if you want to find what is the maximum frequency present in the signal, is nothing but out of all the frequencies, which are the maximum term that we are going to get, that will become the maximum frequency. So what is the FM? FM is nothing but the maximum frequency which is going to present in the signal, which is nothing but maximum value of out of all the frequencies, which is F1, F2, and F3. Out of F1, F2, and F3, what is the maximum frequency that we are going to get? 5000. So 5000 is the FM, which is 5000 hertz. Then you know what is the minimum sampling frequency, which is 2 into FM. So 2 into FM is nothing but 5000. So if we simplify, we are going to get 10,000 hertz. So this is the minimum sampling frequency is 10,000, which is the correct solution of each question. So what I told you, in the time domain, if you are doing addition or subtraction signals, same thing is also going to happen in the frequency domain also. And if you want to find what is the maximum frequency present in a signal, it is nothing but out of all the frequencies, try to see which is having the maximum frequency. That value is nothing but the maximum frequency, which is nothing but FM. So Fs is always greater than or equal to 2 times of FM. But minimum sampling frequency means Fs minimum is equal to 2 into FM. FM is nothing but maximum frequency which is going to be present in the signal. So because of that, you know, FM value 5000, and if you multiply by 2, then we are going to get the minimum sampling frequency is 10,000 hertz. So if you are going to sample the signal with the help of 10,000 hertz, then we can get back the original signal from its sample. So this is the correct solution of this question. So now we are going to solve another question. See the question here. A signal with 2 frequency components at 6 kHz and 12 kHz is sampled at the rate of 16 kHz and then passed through a low pass filter having a cutoff frequency of 16 kHz. The output signal of the filter has, so listen carefully, a signal with 2 frequency components at 6 kHz and 12 kHz is sampled at the rate of 16 kHz and then passed through a low pass filter which is having a cutoff frequency of 16 kHz then the output signal of the filter is. So basically what they're saying is, they are saying that there is a signal which is having only two frequency components, which are the 6 kilohertz and the 12 kilohertz. And now it is sampled at the rate of 16 kilohertz. So now then the signal is passed to a low pass filter which is having a cutoff frequency of 16 kilohertz. Then the output signal of this filter will have in the what type of frequency are present in the output signal of this filter, we need to figure out. So the four options, option D, which is it is going to contain both the components of the original signal and the two superior components of the 4 kilohertz and 10 kilohertz. So what is the meaning of this one? It is going to contain both the components of the original signal, means 6 kilohertz is there, 12 kilohertz is there, and also 4 kilohertz and 10 kilohertz. So these are also present. So these are the original signal frequencies, and these are the extra frequencies which are going to present in the output signal of this filter. So listen carefully. The output signal of the filter is going to contain the frequencies which are of the original signal, which are 6 kilohertz and 20 kilohertz, and also extra two frequencies also present, which are the 4 kilohertz and 10 kilohertz. So option D is the correct solution of this question. So let's solve this numerical. So basically, what is the message signal? The message signal, or you can say the message, the input signal, which is having the frequencies, it is having two frequency components, which are FM1 and FM2. FM1 I am going to assume to 6 kilohertz, and FM2 is nothing but 12 kilohertz. So these are the only two frequencies which are going to present in the signal. These are the only two frequencies which are going to present in the signal. FM1 is equal to 6 kilohertz and FM2 is equal to 12 kilohertz. These are the only two frequency components which are going to present in the message signal. And the signal is now sampled with a sampling frequency of 16 kilohertz. Then the frequencies in a sampled signal. So what are the frequencies which are going to present in a sampled signal? I have already told you that frequencies which are going to present in a sample frequency, or I have already told you what's the general formula. Suppose there is a message signal FM. If it is sampled with the sampling frequency Fs, then the frequencies which are going to present in the frequencies which are going to present in the sampling signal, then the suppose a signal is having a frequency FM. If the signal is sampled with the sampling frequency, then the signal, when the sample signal will have frequencies which are nothing but FM, comma, which is N into Fs plus or minus FM. This formula, as I already told you, where N is nothing but value from starting from 1 to goes on. So this formula, as I already told you several number of times, the frequencies in the sampled signal are, as we have here FM1, so substitute FM1 comma N into Fs plus or minus FM1, and also FM2 comma N into Fs plus or minus FM2. So FM2 comma, actually I should write in the reverse, but here I am writing like reverse because of some approval issue. Actually you have to write like this one. Yeah, let me write here. So let me write here. Okay, anyway it is same, right? Here FM1 comma N into Fs plus or minus FM1. Here FM2 comma N into Fs plus or minus FM2. Here N value is from 1, 2, 3 and goes on. So these are the frequencies which are going to present in the sampled signal. Sampled signal. So this is the frequency which are going to present in the input signal, and by the signal we are going to sample. So because of the sampling, these are the frequencies which are going to present in the sampled signal. So what is FM1? Already we know 6 kilohertz. Just substitute this formula. FM1 is equal to 6 kilohertz and F is 16 kilohertz, and substitute N is equal to 1, N is equal to 2 and goes on. And what you are going to get? Finally you are going to get FM1, which is nothing but 6 kilohertz. Then if you substitute N is equal to 1, what you are going to get? Fs plus or minus FM1. So Fs plus or minus FM1. So if you do the thing, what you are going to get? 10 kilohertz and 20 kilohertz. If you do subtraction, we are going to get 10 kilohertz. If you do addition, we are going to get 20 kilohertz. Similarly, if suppose N is equal to, then what you are going to get? 20 Fs plus or minus FM1. If you do subtraction, we are going to get 26 kilohertz. If you do addition, we are going to get 38 kilohertz. And this will go on. Similarly here FM2 is nothing but 12 kilohertz. If suppose N is equal to 1, then we are going to get Fs plus or minus FM2. If you do subtraction, we are going to get 4 kilohertz. If you do addition, we are going to get 28 kilohertz. Similarly, if N is equal to 2, then we are going to get 2 into Fs plus or minus FM2. If you do subtraction, we are going to get 20 kilohertz. And if you do addition, we are going to get 44 kilohertz. And this will go on. So all these frequencies are going to present in the sample signal. But the signal is now passed through the low pass filter of a cutoff frequency of 16 kilohertz. Means what are the frequencies which are below 16 kilohertz? Only those signals are going to pass through the filter. So now the signal is not passed through low pass filter which is having cutoff frequency. So only those frequencies which are below the cutoff frequency, only those frequencies are going to come out of the filter. So what are those values? 6 is there, 6 is less than 16, yes, this will come out. And also 10 is there, 10 is also going to come out. So from here, from this one, what we can say only 6 and 10 is going to come from here, 6 and 10, remaining all are greater than 16. Here, 12 is also there, which is less than 16. Here, 4 is also there, which is less than 16. So remaining all are greater. So remaining all will never pass. So only from this one, 6 and 10 are going to get passed. From here, 12 and 4 are going to get passed. So overall, what are the frequencies which are passing? 6, 12, 10 and 4. So therefore, the output signal of the filter will have frequencies below the cutoff frequencies, which is less than 16 kilohertz, which are 6 kilohertz, 12 kilohertz, 10 kilohertz and 4 kilohertz. 6 kilohertz and 12 kilohertz are nothing but these are the original signal frequencies, and these are the extra frequencies which are going to come with it. So these are the total frequencies. These are the 4 frequencies which are going to be present in the output as output signal of the filter. So this formula always you have to keep in your mind. So therefore, what I am trying to tell you, the sample signal will have the frequencies which are FM, gamma, N into Fs plus or minus Fn. These are the frequencies which are going to present in the sample signal, and anyway it goes from 1, 2, 3 and goes on. So this point always you have to keep in your mind. So these are the frequencies which are going to present in the sample signal. So if the signal which you are going to pass through filter, so based on the filter frequencies, only those frequencies are going to come out of the filter. But you want to always remember this formula, which is FM, gamma, N into Fs plus or minus Fm. This formula always you have to keep in mind, and N value always goes from 1, 2, 3 and goes on. So this is the correct solution of this question. Now we are going to discuss another question. See the question here. An LTI system has the input signal x of n. So which of the following sequence of operations is most appropriate to get the output y of n is equal to x of n minus m by l? Listen carefully. An LTI system has the input signal x of n. So which of the following sequence of operations is most appropriate in order to get the output y of n is equal to x of n minus capital M by capital N? So see clearly what they are saying is very simple. If they have taken some LTI system, suppose if the input is x of n and the output is y of n is equal to x of n minus m by n, then what is the operations that we need to do on the x of n in order to get y of n, which is x of n minus m by l? Listen carefully. There is a system where we have LTI system. For this LTI system, the input is x of n and the output is y of n. And the y of n is nothing but x of n minus m by l. So what are the operations that we need to do on the x of n in order to get x of n minus m by l? So what are those operations? So are the 4 options option, which is interpolation by l, then delay by m, then decimation by l. If we follow these 3 procedures, then only if you follow these 3 procedures in a stepwise on the x of n, then we are going to get y of n, which is x of n minus m by l. So this is the other solution of this question. So let's solve this numerical. So x of n is the, so let me take here, let me write in a detailed manner. Suppose this is a LTI system. So this is the LTI system. For the LTI system, the input is the x of n and the output is nothing but y of n is equal to x of n minus capital M by l. So what are the operations that we need to do on x of n in order to get y of n? That we need to figure out. So x of n is nothing but first thing. So what I will do, basically, here basically let me take this as the sum. So let me consider this as some function. Let me consider this function as some something. Let me assume this is some y of n only I am going to assume. Basically, what I am trying to tell you is nothing that here basically what are the operations that we need to do on x of n in order to get off x of n minus m by l. So first I will do interpolation by l, means replace n by n by l. So replace n by n by l. That's it. So y of n is nothing but x of n by l. So interpolation by l. So this is the interpolation by l. So here y of n is nothing but x of n by l. So let me write this part. So let me write this part here. so that you can easily able to understand, right? And this is nothing but y of n is equal to x of n by L means interpolation by L. Then what interpolation means? Basically we are expanding the signal, right? We are expanding the signal. We are going to expand the signal from between the 2 points. Suppose let me take here, what is the meaning of this? Let me take here. Suppose x of n is equal to 1 comma 2. So 1 comma 2. So like this it is there. Then what is x of n by 3? N by 3 means n is equal to 0 means 1, n is equal to 1 means 0, n is equal to 2 means 0, n is equal to 3 means, n is equal to 3 means its value is equal to 2. That's it. Remaining things it is 0. So you can see between 1 and 2, we have kept 0, right? This is called interpolation. This is called the interpolation. This is called as the interpolation. So this is called as the interpolation. I think you have understood what is the meaning of this one. So therefore, what I am trying to tell you is very simple. So if substitute n is equal to 3, then you are going to get its value is equal to 3 by 3 is nothing but 1, which is nothing but 2. And remaining things we are going to make it as 0. This is called as the interpolation. Then what I will do? Now I will do shift the signal by m. So here n is nothing but 3 plus n by n minus m. And what you are going to get? X of n minus m by L. So this is called the delay by m. Delay by m. So I am going to have this is P of n, new signal. Again what I will do, decimation by L, means replace n by nl. Then what you are going to get? X of nl minus m by L. So if simplify L cancels, we are going to get n minus m by L. So it is nothing but P of n I am going to assume. Actually, I have to consider this as Q of n. Actually, this should be Q of n and this should be Y of n. That is actual thing here. But I have done in the reverse process. Really the concept is same. Here it should be Q of n. Here it should be Q of n. Here it should be Y of n actually. This is the way that we have to keep in your mind. So therefore now, this is the correct thing. I think now you have understood, right? So this is the thing that you have to keep in your mind. So therefore, whatever I have basically interpolation by L, means represent by n by L. So this I am going to assume Q of n. Then have the delay by m, means replace n by n minus m. Then we are going to get this thing. This I am going to assume P of n. Then what I did, decimation by L means replace n by nl. Wherever n is there, replace n by nl. Then you are going to get x of nl minus n by l. If you simplify, we are going to get x of n minus n by l, which is nothing but y of n. So this is the correct solution of this question. So what we have to do first thing is interpolation by L, means replace n by n by L. Then delay by m means replace n by n minus m. Then decimation by L means replace n by nl. Listen carefully. Interpolation by L means replace n by n by L. Delay by m means replace n by n minus m. Decimation by L means replace n by nl. So listen carefully. Interpolation by L means replace n by n by L. Delay by m means replace n by m minus m. Decimation by L means replace n by nl. So if we do these three things, finally we are going to get y of n is nothing but x of n minus m by n. I think now you have understood, right? So therefore this is the correct solution of this question. So first we have read the interpolation by L means replace n by L. Then delay by n means replace n by n minus m. Decimation by L means replace n by nl. So you follow all these things, finally you are going to get the output. Y of n is equal to x of n minus m by L. So this is the correct solution of this question. So now we are going to solve another question. See the question here. The question says that 4-0 plot of a digital filter is shown below. So what is the type of the filter they are asking? Is shown in the below figure. The 4-0 plot of a digital filter is shown below. So what is the type of the filter? So basically this is the jet plane. So this is the jet plane. So this is the jet plane. This is the rear part of the jet and this is the imaginary part of the jet. So what in the jet plane they have shown the 0 as 2 and the pole as 0.5. This might be unit circle. This might be a unit circle, but we don't require. But only we need to say what is the 0 as well as the pole. So from this we have to tell what is the type of the filter we need to comment. So the four options, option D, all pass filter is the correct solution of this question. So let's solve this numerical. So basically we can say same thing. We have drawn the picture. Is the real part of the jet and is the imaginary part of the jet and is the jet plane. Here the 0 is at 2 and the pole is at 0.5. So this is the pole 0 plot of the digital filter. So this is h of z. What is the transfer function h of z? 0 by pole z minus 2 by z minus 0.5. So this is the transfer function that we are going to write from the pole 0 plot. h of z is z minus 2 by z minus 5, because z plane means you have to take z, s plane means you have to take s. Very simple, right? So z plane means take z, s plane means take s. So z minus 2 by z minus 0.5. So if you simplify, 0.5 is nothing but 5 by 10 is 1 by 2. So simplify, we are going to get 2z minus 4 by 2z minus 1 that we are going to get. So this is basically the h of z, which is nothing but z transform. But I want to find what is the Fourier transform. Fourier transform means discrete Fourier transform is replace z by e to the power of j omega. I have already told you. If you want to basically this is h of f is nothing but the z transform of the h of n. The z transform of the h of n. But I want to find what is the discrete Fourier transform of h of n, which is h of e to the power of j omega. Means wherever z is there, replace z by e to the power of j omega. Then what we are going to get? Very simple. Wherever z is there, replace z by e to the power of j omega. Then we are going to get 2 into e to the power of j omega minus 4 by 2 into e to the power of j omega minus 5. I have already told you, the z transform, if you replace z by e to the power of j omega, we are going to get the discrete Fourier transform basically on the h of n. Because on the h of n, if you perform the z transform, we are going to get h of z. On the h of n, if you try to find discrete Fourier transform, then we are going to get h of e to the power of j omega. So in the z transform, if substitute is equal to the power of j omega, then we are going to get the corresponding discrete Fourier transform. So now I will see what is the, for different values of omega, what is the thing that I am going to get. Let us see here. So now listen carefully. This is omega and this is the magnitude part. This is the magnitude part I am going to consider. Suppose if omega is equal to 0, then what we are going to get here? We will substitute e to the power of 0 is nothing but 1. So 2 minus 4 by 2 minus 1. 2 minus 4 is nothing but minus 2. Minus 2 by 1 is nothing but minus 2. But you have to take the magnitude part. Magnitude part means only the magnitude part we have to consider, it is equal to 2. So 2 we have 1. You substitute pi by 2. Then add 2 into e to the power of j pi by 2 minus 4 by 2 into e to the power of j pi by 2 minus 1. E to the power of j pi by 2 is nothing but j by j. So 2 into j minus 4 by 2j minus 1. Take the magnitude. Another dot 2 square plus 4 square by another dot 2 square plus 1 square. It is nothing but another dot 2 square is 4. 4 plus 16 is nothing but 20. By 4 plus 1 is nothing but 5. So another dot 20 by 5 is nothing but 5 for that. So root 4 is nothing but 2. So 2 value we have got. Similarly, if substitute pi, then what we are going to get? We substitute pi. Then 2 into the power of j pi minus 4 by 2 into the power of j pi minus 1. If the power of j pi, if the power of j pi is nothing but simply we are going to get minus 1. So minus 2 minus 4 by minus 2 minus 1. Minus 2 minus 4 is nothing but simply minus 6 by minus 3. Minus 1 is cancelled, 3 on the equation. So 2 we are going to get. So you see, for different types of omega, same value that we are going to get. The magnitude value is same. So we can say this is a all pass filter. So if you draw the picture, what we are going to get? So let me draw. Let me rub this all these things. I think people we may see very confused. So let me rub this part. So now you can see clearly. It is, if you see the graph, the amount of h of e to the power of j omega for all values of omega, its value is always equal to 2. So therefore we can say this is nothing but an all pass filter. So therefore we can say this is called as an all pass filter. All pass filter means it is going to pass all the frequencies from input to output, but it is going to provide only some amount of phase shift for the input signals. But it is not going to provide any magnification. It will pass all the frequencies from input to output, and it's going to provide only some amount of phase shift. So you can see clearly here. So you can say all the frequencies are passed from input to output. So all the frequencies are passed from input to output. So we can say this is called as the all pass filter. So this is the picture of the all pass filter. So this is the correct solution of this question. So now let's go for the another question. See the question here. The Fourier transform of the signal x of t will be the power of minus 4 into mod t. So basically this question they are asking what is the Fourier transform of the signal x of t which is equal to the power of minus 4 into mod t. They are asking this question. So x of t is nothing but the power of minus 4 into mod t. So for this signal, we have to find what is the Fourier transform we need to figure out. For e to the power of minus 4 into mod t, for this signal, we have to find what is the Fourier transform we need to figure out. So the four options, option A is the correct solution of this question. So let's solve this numerical. So now, basically, listen carefully. I already told for e to the power of minus 80 into u of t, what is the Fourier transform? 1 by a plus j omega. I already told you, right? E to the power of minus 80 into u of t, what is the Fourier transform? 1 by a plus j omega. Because I already told you, for e to the power of minus 80 into u of t, what is the Laplace transform? 1 by s plus a. So in place of a, if we substitute j omega, we are going to use the Fourier transform, which is 1 by a plus j omega. So now replace t by minus t. So replace t by minus t means e to the power of 80 into u of minus t. For this Fourier transform is replace omega by minus omega, and we are going to get 1 by a minus j omega. I already told you, if f of t has the Fourier transform f of omega, and f of minus t has the Fourier transform f of minus omega. If you are replacing t by minus t means replace omega by minus omega. So e to the power of 80 into u of minus t has the Fourier transform 1 by a minus j omega. So now do the addition of these two segments. Then do the addition of these two things also. If we are doing addition of these two things, then do the addition of these two things also. E to the power of minus 80 into u of t plus e to the power of 80 into u of minus t. What is the Fourier transform? Do the addition of these two things. 1 by a plus j omega plus 1 by a minus j omega. So do the LCM. What we are going to get here? LCM is a plus j omega into a minus j omega. It is nothing but a square minus j omega whole square. It is nothing but a square plus omega square. Here a minus j omega plus a plus j omega. J omega cancels. We are going to get 2a by a square plus omega square. So e to the power of 80 into, see, e to the power of minus 80 into u of t plus e to the power of 80 into u of minus t. This is nothing but e to the power of minus a into mod t. Because I have already told you, mod t is nothing but, see, mod t is equal to plus t for t greater than or equal to 0, and it is equal to minus t for t less than or equal to 0. So now what I can say, for t greater than 0 means 3 plus t by mod t by t. So you are going to get this thing. Suppose for t less than or equal to 0, 3 plus mod t by minus t. Then what you are going to get e to the power of minus a into minus t, is nothing but e to the power of 80. So you can see clearly this is nothing but e to the power of minus a into mod t. So e to the power of minus a into mod t has a Fourier transform 3a by a square plus omega square. So e to the power of minus a into mod t has a Fourier transform 3a by a square plus omega square. So it's up here. A is nothing but 4. And the question they are asking with the power of minus 4 into mod t Fourier transform. So by comparing this, we can say A is nothing but 4. So in place of A substitute 4, then you are going to get 2 into 4 by 4 square plus omega square. This is nothing but 8 by 16 plus omega square. So this is the correct solution of this question. So if you know one thing, getting the other things is a very piece of cake. So e to the power of minus a into mod t as the Fourier transform 3a by a square plus omega square. So by comparing the value of a is equal to 4 and substituting the value of a is equal to 4 in this expression, and if you simplify, we are going to get the value which is 8 by 16 plus omega square is the correct solution of this question. So now we are going to solve another question. See the question here. For the system shown in the figure, P of t is the error between the input and the output. So for the system shown in the figure, P of t is the error between the input x of t and the output y of t. If x of t is equal to t into u of t and all the initial conditions are 0, then e of t will be. So if you see clearly, for the given system shown in the figure, if e of t is the error between the input as well as the output, and if x of t is equal to t into u of t and all the initial conditions are assumed to be 0, then what is the value of the e of t? What is the expression of e of t? They are asking this question. So if you see clearly, this is a feedback system. The e of t is nothing but here minus is there, here plus is there, means e of t is equal to minus into x of t plus y of t, means e of t is equal to y of t minus x of t. And here this is a input output relation. Input is e of t and output is y of t. So between this they are given some relation. So basically they want to find what is the expression of the output e of t they are asking, which is nothing but minus sin t is the correct solution of this question. So let's solve this numerical. So same graph I have drawn. So here the input is x of t, the output is y of t. They are taking feedback the positive negative is e of t, and this is a system input output equation with this square dt square is equal to minus into e of t. So what is x of t? They have given t into u of t. For this input and all the initial conditions are 0, then what is the output? Then what is the e of t we need to figure out. So what is x of s? What is the Laplace transform? 1 by s square, because we need a basic formula. For e to the power of n into u of t, what is the Laplace transform? In fact, is the power of n plus 1. This one I have already told you. For t to the power of n into u of t, what is the Laplace transform? In fact, is the power of n plus 1. So by using this formula, substitute n is equal to 1, we are going to get 1 by s square. X of s is equal to 1 by s square. Then what is e of t? I have already told, which is y of t minus x of t. So e of t is equal to y of t minus x of t. So apply the Laplace transform on both sides, then what we are going to get E of s is equal to y of s minus h of s. And also what is the differential equation to d square over d square is equal to minus into e of t. Or we can say e of t is equal to minus d square over dt square. And you see clearly here multiply minus on the both sides. Then what you are going to do, e of t is equal to minus t square over dt square. Then what I am going to do, I am going to apply the Laplace transform on the both sides. Then what I am going to do, e of s is equal to minus s square into y of s. Very easy thing. And what is y of s? Y of s is equal to minus e of s by s square. As you can clearly forget from this expression. But you know what is e of s? E of s is equal to y of s minus x of s. But y of s, you know, what is the y of s now? It is nothing but this one. That should be minus e of s by s square. So take this e of s to the LHS, then what you are going to e of s common, then you are going to get 1 plus 1 by s square is equal to minus 1 by s square. So if you do the simplification, and finally you are going to get e of s is equal to minus 1 by 1 plus s square, but you are going to do the simplification. So you know the basic formula for sin 80, what is that? Sin 80 into u of t. Basically, we have to write here sin 80 into u of t. Sin 80 into u of t is Laplace transform a by s square plus a square, and cos 80 into u of t is Laplace transform s by s square plus a square. So by comparing this one, what I can say, that a is equal to 1. So this is nothing but sin t, but there is a minus, so minus sin t. So minus sin t, that we are going to get the expression which is nothing but minus sin t. So by comparing this one, what I can say, a is nothing but 1. There is a minus here, so keep it minus as it is. So minus sin t, that we are going to get. But if you want the exact expression, means e of t is equal to minus sin t into u of t, you have to write. If you want the exact expression. So therefore, I can say that this is a very simple thing. So always remember sin 80 into u of t as a Laplace transform a by s square plus a square, and cos 80 into u of t as a Laplace transform s by s square plus a square. So these formulas always you have to keep in your mind. So sin 80 into u of t is a Laplace transform a by s square plus a square, and cos 80 into u of t as a Laplace transform s by s square plus a square. So finally, always remember for t to the power of n into u of t, the Laplace transform is n by t by s to the power of n plus 1. And for sin 80, the Laplace transform is a by s square plus a square, and cos 80 as a Laplace transform s by s square plus a square. These formulas always you have to keep in your mind. So this is the correct solution of this question. So now we are going to solve another question with the question here. Basically, x of t is equal to cos of 10t into cos of 100t is passed through a system whose impulse response is h of omega is equal to exponential of minus j10 minus j2 into omega minus 100. If y of t is the system output, then what is the expression? So if you see clearly, they are given some system. For this system, the impulse response is h of t, but they are given the Fourier transform of this h of t. They are given the expression. And also, input expression also they are given x of t. So from this we have to find what is the output expression that we need to figure out. So the four options, option C is the correct solution of this question, which is y of t is equal to cos of 10 of 2 minus t minus 2 into cos of 100 of t minus 1 is the correct solution of this question. So let's solve this numerical. So basically, this is the LTI system. What is the LTI system? The input is x of t and output is y of t, and the impulse response is h of t. But in the question, we are given the Fourier transform of the impulse response, which is h of j omega, h of omega also you can say. The Fourier transform of h of t, which is h of omega, h of j omega. So what they are given, x of t is nothing but cos of 10t into cos of 100t they are given. And h of j omega or h of omega, you can take anything. This is nothing but e to the power of exponential means e to the power of minus j 100 minus j2 into omega minus 100 they are given. So from this, we have to find what is the output y of t we need to figure out. So output y of t we need to figure out. So what is x of t? Cos 10t into cos 100t. So now I am going to use this formula. Cos a into cos b is nothing but cos a plus b plus cos a minus b by 2. So I have already told you what is the basic formula, cos of a plus b. So cos of a plus b is equal to cos a into cos b minus sin a into sin b, right? Similarly, cos of a minus b is equal to cos a into cos b plus sin a into sin b. Suppose if we add these two things, what we are going to get? Cos a plus b plus cos of a minus b. Then what we are going to get? We are going to get 2 cos a cos b But I want only cos A into cos B. Then what you have to divide by 2. So cos of A plus B plus cos of A minus B by 2 is nothing but cos A into cos B that we are going to get. Same thing I have written here. Same thing I have written. So cos A into cos B is nothing but cos of A plus B plus cos of A minus B by 2. Here A is nothing but 10t and B is equal to 100t. We substitute here. X of t is nothing but half of cos of addition of these two things. 10t plus 100t is equal to 120 plus cos of 10t minus 100t is nothing but minus 90. And you know cos of minus theta is equal to cos theta. So it will remain as it is. So cos 90t plus cos 120 by 2. As I already told you, cos of minus theta is equal to cos theta. And taking off inside, in what you are going to get x of t is half into cos 90t plus half into cos 110t. So this is the expression of the input. I have written in the summation format. Previously it is in the product format. So now I am written in the summation format. Then what is y of t? So I have already told you one important thing for an LTI system. Listen carefully. This one I have already told you so many number of times. Suppose this is if the input is x of t and this is the h of omega or h of j omega. Anything we can say transfer function. And this is the y of t. I have already told you, suppose if x of t is equal to a into either sin or cos omega 1t plus phi. It is there like this. Suppose it is there like this. Then what is y of t? Y of t I have already told a into magnitude of the h of omega at omega 1 into sin of omega 1t plus phi plus base angle of h of omega at omega 1. I have already told this formula. So the amplitude is going to scale by the magnitude of transfer function and the base angle that we need to going to add. So by this formula we are going to solve this question. So now what is the y of t? See, half will be same as it is. Half is same. Half into what is the magnitude of h of omega? What is omega here? 90. So omega is equal to 90. The cos means here also cos of 90t plus what is the phase angle of h of omega? Omega is equal to 90 plus again half into magnitude of h of omega at omega is equal to 110 into cos of 110t plus phase angle of h of omega at omega is equal to 110. Based on this one, based on the previous formula, what I can say, y of t is nothing but half into magnitude of h of omega at omega is equal to 90 into cos of 90 plus phase angle of h of omega at omega is equal to 90 plus half into magnitude of h of omega at omega is equal to 110 into cos of 110t plus the phase angle of h of omega at omega is equal to 110. I wanted to this formula, right? So now what is h of omega? H of omega already they have given, which is e to the power of minus j 110 minus j 100 minus j2 into omega minus 100. So now basically I want to substitute at omega is equal to 90. I want to find the magnitude as well as the phase angle. So in the place of omega I will substitute 90. So h of omega at omega is equal to 90. I am going to substitute. So in place of omega, if I substitute 90, then 90 minus 100 is minus 10. So minus 7 into minus 2 is nothing but plus 20. So minus j100 plus j20. So if simplify, we are going to get minus 80j. So e to the power of minus 80j. So h of omega at omega is equal to 90 is equal to e to the power of minus 80j. So this is basically polar format. What is the magnitude? Magnitude is 1. What is the phase angle? Minus 80. Because you know, e to the power of I theta, e to the power of I theta, for e to the power of I theta, what is the phase angle? Theta, and the magnitude is 1. We have already told for r into e to the power of I theta, the magnitude is r and the phase angle is theta. So here we can see the magnitude is 1 and the phase angle is minus 80. So 1 and the phase angle of minus 80. Similarly, h of omega at omega is equal to 110. I want to substitute this. In case of omega, substitute omega is equal to 110. And what we are going to get? 110 minus 100 is nothing but plus 10. So plus 10 to minus 2 nothing but minus 20. So e to the power of minus j 100 minus 20j. So if we simplify, what you are going to e to the power of minus 120j. So h of omega at omega is equal to 110. We are going to get e to the power of minus 120j. So what is the magnitude value? The magnitude value is nothing but 1 and the phase angle is nothing but minus 120. Because we already told you for r into e to the power of theta, the magnitude is r and the phase angle is theta. So therefore the magnitude is 1 and the phase angle is minus 120 degree. This is basically degree. Degrees. So now just substitute these values. So you know magnitude part and you know everything. So half into what is the magnitude of h of omega at omega is equal to 90, its value is 1 into cos of 90t plus What is the base angle of h of omega at omega is equal to 90 degrees minus 80 degree. Similarly, if we solve into the amount of h of omega at omega is equal to 110 is nothing but 1 into cos of 110t plus what is the base angle? This is basically minus here. This is minus 80 plus what is the base angle of h of omega at omega is equal to 120 is minus 120. This is a degrees. So if you simplify, what you are going to get y of t is equal to half common cos of 90t minus yt plus cos of 110t minus 120 degree. So this is what you are going to get. Same thing I have written. Y of t is equal to half into cos of 90t minus 80 plus cos of 110t minus 120. So this is the output expression. But if you see in the options, this is not there. So this is not there in the options. We have to do further simplification of this one. So now I have already told you what is cos a minus b plus cos of a plus b. I have already told you which is 2 cos a cos b. Question we have discussed. So now I am going to substitute a plus b is equal to x and a minus b is equal to y. I am going to assume. So listen carefully. A plus b I am going to assume it is x and a minus b is equal to y. Then what I am going to get? So a minus c a plus b is equal to x means cos x plus cos y is equal to 2 into what is the value of a? If you simplify, a value is nothing but s plus y by 2, s plus y by 2, and b is nothing but x minus y by 2. That's it. So 2 into cos of s plus y by 2 into cos of x plus y by 2. Just what you did, cos a minus b plus cos a plus b is equal to cos a cos b. I am going to assume a minus a plus b is equal to x and a minus b is equal to y. If you simplify, you are going to get the value of a, which is s plus y by 2 and b is equal to x minus y by 2. So here this is the cos x plus cos y is equal to 2 into cos of s plus y by 2 into cos of x minus y by 2. So now what I am going to do? So this is cos x. So this is nothing but x. This is nothing but x. This is nothing but x. And this is nothing but y. This is nothing but y. Right? Understood? So basically now I want to simplify from addition to multiplication. Basically this is addition, right? I want to convert from addition to multiplication. So I have to use this formula. Previously from multiplication to addition we have did. But now from addition to multiplication I want to do. So you have to use this formula. So cos x plus cos y is equal to half it is there already. We will keep as it is. Half into 2 of cos of s plus y. This is the addition of these two things. The addition of these two things. 90t plus 110t is nothing but 200t minus 80 minus 120 is minus 200. So 200 minus 200 by 2 into cos of subtraction. 90t minus 110t is nothing but minus 20t. Minus 80 plus 120 is nothing but plus 40 by 2. So if you simplify, what you are going to get? If you simplify, divide by 2, if 2 cancels, you are going to get cos of 100t minus 100 into cos of 2 cancels, what you are going to get? Minus 10t plus 20. So take your minus common and you know cos of minus theta is equal to cos theta. So from that we can say cos of 100t minus 100 into cos of 10t minus 20. So here I will take common, here take 10 as a common. Then what you are going to get? Y of t is equal to cos of 100 of t minus 1 into cos of 10 of t minus 2. So this expression is there in the result in our options. So this is the correct solution of this question. So basically previously we have converted from multiplication to addition and now we have converted from addition to multiplication. So this is the correct solution of this question. Now we are going to solve another question. See the question here. A signal x of t is band limited to w hertz and y of t is equal to x of t whole cube plus x of t plus 1. The Nyquist sampling frequency of y of t is. So basically they have given a signal x of t. It's a band limited to w hertz, means the maximum frequency which is going to present in the x of t signal is nothing but w hertz only. Then y of t is equal to x of t whole cube plus x of t plus 1. Then what is the Nyquist frequency? The Nyquist sampling frequency of y of t we need to find. So I have already told you what is the meaning of Nyquist sampling frequency or Nyquist rate. It is nothing but the minimum sampling frequency in order to get the original signal from its samples. So what is that we need to figure out? So the four options, option B, 6W is the correct solution of this question. So let's solve this numerical. So as you can see clearly, x of t is nothing but they are given a signal x of t is having a band limited to w hertz, means the maximum frequency which is going to available in x of t is nothing but w hertz only. So if I wanted to graph the if I want you to draw the graph, how is going to become? Say this is the x of t, x of the frequency domain. Band limited means it is going to present up to only certain frequency. So let me assume this is the graph we are going to get. So this is the w hertz. So this is omega. This is omega and this is a w hertz. So what is the maximum frequency? Fm is nothing but the maximum frequency which is going to present in a signal is nothing but W is equal to W. So you can see clearly for x of t, maximum frequency is going to present in a signal is equal to W hertz. And y of t is nothing but it is x of t whole cube plus x of t plus 1. So y of t is nothing but we are going to get the simple x y of t from x of t, which is nothing but y of t is equal to x cube of t plus x of t plus 1. So now let us see for each and everything what is the frequency. So for x of t, the frequency is W, then x cube is 3 times that one, which is 3 into W hertz. And x of t is nothing but W hertz only. And for 1, it is a DC signal. So what is the frequency of this signal, which is equal to 0 hertz. I already told you, whenever you are going to the addition of signals or subtraction of signals, the maximum frequency which is going to available is nothing but the maximum value of the individual frequencies, which is the maximum value of 3 hertz 3W, W and 0 is nothing but 3W. So I have the maximum frequency available is nothing but 3W hertz, it is nothing but FM. And I have already told you the minimum sampling frequency is equal to 2 into FM, which also follows a Nyquist rate. So 2 into what is the FM? 3W. So if you solve this one, we are going to get 6W. So the Nyquist rate or the Nyquist sampling frequency, which is equal to 6W versus the correct solution of this question. And I've already told you so many number of times. Whenever the sampling frequency is greater than or equal to 2 times the message signal frequency. The message signal frequency is nothing but this is FM. So 2 into FM, here FM only if you have only one signal. If you have only one signal with only one frequency. Suppose if a signal has more than one frequency, then the formula is F is greater than or equal to 2 times of the maximum value of out of all the frequencies F1 comma F2 comma like this. I've already told you so many number of times. Here F is greater than or equal to 2 into Fn. This is the formula where the signal is having only one frequency. But if the signal has more than one frequency, then 2 into maximum value of the individual signal frequencies. So out of this, whichever is the maximum that you have to use in order to solve this one. So minimum sampling frequency is equal to 2 into Fn. So Fn is substance simplify and get the value of the Nyquist rate or the Nyquist sampling frequency, which is equal to 6 into W. And I've already told you an important point. See, suppose x of t is having the frequency F, then x square of t has a frequency 2F, I've already told you, and x cube of t has a frequency 3F. So this formula, as I already told you, so the number of times. Because the product in the time domain and the product in the time domain will become in the frequency domain, it is going to become convolution, right? Convolution. I already told you the product in the time domain is going to become convolution. Convolution is nothing but then what is the maximum frequency how to calculate, which is the summation of all the frequencies, which is summation of the all the frequencies. So each signal frequency is F, so F plus up to n times that we are going to the product here. Summation of all the frequencies. This one I have already told you so many number of times. As signal is multiplied 2 times, so we have to add the frequency 2 times. Here, the signal is multiplied 3 times, then we have to add the signal frequency 3 times, 3 into F. I have already told you the product in time domain is reached to convolution in the frequency domain. So convolution is basically what is the maximum frequency? The maximum frequency is nothing but it is addition of all the frequencies. So it is basically the addition of all the frequencies of each and every signal. So if x of t is multiplied 2 times, then we have to add the signal frequency 2 times just to get. The signal is multiplied 3 times, then we have to add the frequency 3 times just to get. Similarly for x of t all the power of n. So for x of t all the power of n, what is the signal frequency n into n? So this point always you have to keep in the mind. So therefore you can see finally this has a frequency 3 into W hertz. This will have W hertz and this is the DC, so its frequency is 0. So out of this, we decide the maximum frequency 3W and multiply by 2 in order to get the sampling minimum sampling frequency, which is 6W hertz is the correct solution of this question. So now we are going to solve the another question. See the question here. The Z transform x of z of a sequence x of n is given by. So the Z transform x of z of a sequence x of n is given by. So basically there is sequence x of n and that we are going to do the Z transform and we got x of z which is equal to get to the power of 21 z minus half into z minus 2 into z plus 3. So you see clearly there is some signal x, there is some discrete signal x of n. If I do z transform on that, I have got the x of z which is appear. Get to the power of 21 z minus half into z minus 2 into z plus 3. If x of z converges for mod z is equal to 1. If x of z converges for mod z is equal to 1. What's the meaning of this one? If x of z is going to convergence for mod z is equal to 1 means in the ROC of x of z, mod z is equal to 1 is there means the ROC is going to present, the unit circle is going to present in the ROC. The unit circle is going to present in the ROC. What is the meaning of ROC? If you substitute all the points of the ROC in the x of z, you are going to get a finite value. That is the meaning of the ROC. As in the question itself, they have told that if x of z is going to converge from mod z is equal to 1 means each and every point on the unit circle, if you substitute all these points in x of z, we are going to get a finite value. So therefore, you can say that in the ROC of the x of z, the unit circle is present. Then x of minus 18 is, means x of minus 18 means at n is equal to minus 18, what is the value of the x of n? 0 to 0. So out of the four options, option B, which is minus 2 by 21 is the correct solution of this question. So let's solve this numerical. So x of z, they have given, which is nothing but z to the power of 20 by z minus half into z minus 2 into z plus 3. So in the question what they have given, which is x of z is going to convergence for the mod z is equal to 1. It means that ROC of the x of z is contains the unit circle. So we already told you that what's the meaning of ROC. The ROC means basically you can say region of convergence, means if you substitute those points in x of z, you are going to get a finite value because x of z is going to get converged. As they already mentioned that is all the points in the unit circle, they are going to get converged, means the ROC of the x of z is going to include the unit circle. Then what are the poles? The poles are the denominator roots. The denominator roots are called poles which are half comma 2 comma minus 3. The poles are half comma 2 comma minus 3. So now see basically these are the poles, but I want to find what is the magnitude of the poles. What is the magnitude of the poles? The magnitude of the poles is nothing but the magnitude of the poles is equal to, we take the absolute value of comma 2 comma with the magnitude of the poles. So now draw the circles of radius of radius 2 and of radius 3. So in the z plane, it's a real part of z and it's a imaginary part of z. So this is a circle of radius of, this is a circle of radius 2, this is a circle of radius 3. So now if I want to plot these poles, the poles are half means half comma 0, 2 means 2 comma 0, minus 3 means minus 3 comma 0. So here I have plotted the poles which are half comma 0, 2 comma 0 and minus 3 comma 0. I have plotted the poles also. So now what is the ROC of x object? So now I want to find what is the ROC of the x object. See here it is a half, here it is a 2 and here it is a 3. So 1, where 1 is present, the unit circle is going to present between the half as well as the 2. So the unit circle is going to present between the radius half as well as 2. So what is the ROC? The ROC must be this one. The ROC must be this one because here ROC cannot be other. See, ROC must be only in this region. Why it is like this? Very simple. Why it is like this? What is the meaning of this one? The ROC is going to lie in this region from half to 2. So what is the ROC of the x object, which is nothing but half less than mod z less than 2. So this is the ROC because only in this region it is going to contain the unit circle and also it is not going to contain the poles. So it is not going to contain the poles because the ROC is never going to include the poles. So this is the only thing which is going to get satisfied, which is going to satisfy the condition because the ROC must include the unit circle and also it must not include the poles. So then it indicates that only this is the ROC that is going to get available. So the ROC of the x object is nothing but half less than mod z less than 2. So from this what I can say, at the pole of what we are going to get, the ROC must be outward, means we are going to get a right sided signal. Similarly at 2, the ROC must be inside. It means that the signal is a left sided signal. At the 3, the ROC must be inside, then only we are going to get a left sided signal. So the combination of the intersection of the ROCs of all these things, then only we are going to get this ROC. So at half you should get a right sided signal, at 2 you should get a left sided signal, and at 3 you should get a left sided signal. Then only the net ROC is the combination of all these 3 ROCs. We are going to get this one. So therefore we can see what is the x object by z to the power of 20. So z to the power of 20 I have taken down here. Then I got 1 by z minus half into z minus 2 into z plus 3. So by partial fractions, what we are going to get? So basically I want to use the partial fractions in order to simplify this expression. Then I am going to get x of z by z to the power of 20 is nothing but a by z minus half plus b by z minus 2 plus c by z plus 3. So this is the expression that I want to get, that I am going to get after doing the partial fraction, which is x of z by z to the power of 20 is equal to a by z minus half plus b by z minus 2 plus c by z plus 3. So now what I want to do is very simple. Basically, I want to calculate the value of a. So if I want to calculate the value of a, then I have to substitute z is equal to half in the remaining terms. We remove this term, and in the remaining term, just substitute z is equal to half. Then what you are going to get 1 by half minus 2 into half plus 3. So if you simplify, you are going to get minus 4 by 21. Similarly, I want to calculate the value of b. So z is equal to 2, you have to substitute, except in this term, remaining term, substitute z is equal to 2. Then b value you are going to get 1 by 2 minus half into 2 plus 3. To simplify, we are going to get 2 by 15. Similarly, I want to find what is the value of c. So just remove this z plus 3 term and substitute z is equal to minus 3 in the remaining terms. Then we are going to get c is equal to 1 by minus 3 minus half into minus 3 minus 2. When we simplify, we are going to get its value is equal to 2 by 35 you are going to get. So a value is minus 4 by 21, b value is 2 by 15, and c value 2 by 35. Let's substitute these values in this way. In this one, we are going to get x of z to the power of 20 is equal to minus 4 by 21, z minus half plus 2 by 15, z minus 2 plus 2 by 35 by z plus 3. I already told you, at half, what we are going to get, the right side signal we are going to get. So ROC is output. So to satisfy the ROC, this ROC is output. I want to tell you, in order to satisfy this ROC, this signal must have a ROC output. This right side signal. Similarly, at this point, z is equal to 2, in order to satisfy the ROC of x of z, this must be a left sided signal. So to satisfy the ROC, this ROC is invert the circle. Similarly, at z is equal to minus 3, means this one, in order to satisfy this ROC, the signal should be a left sided signal because the ROC is invert. So you have to satisfy the ROC, this ROC is invert. This is a very common thing that I don't need to explain. So x of z to the power of 20 is equal to, what I will do, basically, I will write with different fashion, which is minus 4 by 21 into 1 by z minus half plus 2 by 15 into 1 by z minus 2 plus 2 by 35 into 1 by z plus 3. Same thing I have done just already. This is the constant outside. So I have written like this. So now what I will do, very simple. I will multiply z to the power of 20 inside, but z to the power of 19 I will take outside, and the remaining things I will multiply by z. And then what I am going to do, very simple. Basically, x of z is equal to z to the power of 20 into all these things. Then what I will do, z to the power of 19 I will take inside, outside, and z I will multiply inside each and every term. So like this we are going to do. So what we are going to get now finally, x of z is equal to z to the power of 19 into minus 4z by 25 into z minus half plus 2z by 15 into z minus 2 plus 2z by 25 into z plus 3. So now this is the expression that we have got. Now by doing the inverse z transform, what we are going to get. So by doing that inverse z transform, we are going to get the value of x of n, which is minus 4 by 21 into 1 by 2 whole the power of n plus 19 into u of n plus 19, minus 2 by 15 into 2 to the power of n plus 19 into u of minus n minus 1 minus 19, minus 2 by 35 into minus 3 whole the power of n plus 9 into 19 into u of minus n minus 1 minus 19. So this is the expression that we are going to get. So if we simplify, this first term is same as it is everything. Second term, minus 1, minus 7 is equal to minus 20. Remaining thing is sum, just I get minus 20 here. Minus 1, minus 7 is nothing but minus 20. And remaining thing everything same as it is. So this is the final x of n value we have got. So now, I will tell you how I got this one also. I will tell you, but you just wait for 2 minutes. Now, basically in the question we have found what is the value of x of minus 18 means in place of n, substitute minus 18. So if you substitute in place of n minus 18, what you are going to get? Minus 4 by 21 into half whole the power of minus 18 plus 19. Here, minus 18 plus 19 is plus 1. So we have found this 1. Whereas the remaining things, here minus 18 means what you are going to get? Plus 18 minus 20, which is negative. So u of negative is nothing but 0. So this value is 0. Similarly here, if you substitute minus 18, what you are going to get? Minus of minus plus 18 minus 20 is minus 2. Again, its value is equal to 0. So these two terms we are going to get 0 value. Only this term we are going to give some finite value, which is, if you simplify, what we are going to get? Minus 18 plus 9 is equal to plus 1. So minus 4 by 20 into 1 by 2 is nothing but minus 2 by 21. So this is the correct solution of this question. So basically what we have to do is very simple. They are given the x object. Then they are also given the at m of z is equal to 1. We are going, the x of z is going to get converged means RS is going to include the unit circle. So based on the poles, we have calculated what is the ROC. From that we have known at what pole, what is the nature of the signal, either the right side or left side also we have figured out. And with the partial fractions also we have expanded. And with the help of inverse transform, we got the x of n. After knowing the x of n, is substitute n is equal to minus 18, then we got the solution, which is minus 2 by 21. But now let me tell you how we got this expression, let me tell you. So final answer is x of minus 18 is equal to minus 2 by 21. The formulas that you have to remember, a to the power of n into u of n have the transform z by z minus a. Which is the right side signal. So the ROC is order of the circuit is greater than mod A. But A can be positive, A can be negative, or A can be complex number. Similarly, minus a to the power of minus into a to the power of n into u of minus n minus 1. This z transform is something the same as it is z by z minus a. Z by z minus a. Now, its ROC is opposite of this one. Here z is greater than mod A. So here it will be z is less than mod A. Mod A is less than mod A. So therefore, here the ROC is outward. So here the ROC is inward. Both are reverse. Opposite we can say. Both are opposite we can say. I have already told you this formula also so many number of times. The formula is if f of n into u of x has some z transform, some z transform is there. Let me also here z is there, some z transform. With an ROC, some ROC is there. Now similarly minus f of n into u of minus n minus 1 will also have the same z transform, but the ROC is reverse ROC. Reverse of the previous one. This formula I already told you. If f of n into u of n has z transform, we have z is the ROC. Minus into f of n into u of minus n minus 1 has the same z transform, but ROC is reverse of the previous one. Opposite we can say. Same thing we can say. Same this is also going to f of n is z to the power of n. So by using this formula, the transform is same as it is, but the ROC is reverse opposite of ROC. Yet this more than greater than mod A is here, more than is less than mod A. As you can see, this is the right side signal, so ROC is outward. This is the left side signal, so the ROC is inward. So now, let me tell you the other promise also. If f of n has z transform, f of z, if f of n has z transform, f of z, then f of n minus n naught has z transform, z to the power of minus n naught into f of z, and f of n plus n naught has z transform, z to the power of plus n naught into f of z. This one I have already told you. Here minus means here minus, here plus means here also plus. These formulas also I have already told you. Now let us see how with the help of these formulas how we got this expression. So minus 4 by 21 is kept as it is, right? We have taken outside. Now tell me z by z minus a, z by z minus a. As at top here we only get the ROC is output. So this is the right side signal. So use this one. And this one a to the power of n into u of n. Here is nothing but half. So it should be actually what it should be after the power of n into u of n. Actually it should be like this, but there is a z to the power of 19 is there. Z to the power of 19 is what it will become? Let's replace n by n plus 19. So what we are going to get now? Finally, after the power of n plus 19 into u of n plus 19. Same thing. Similarly here, at the base equal to 2. We should get a left side signal. Means the ROC is inward. When you have to use this formula, you have to use z minus a. A is nothing but here 2. So minus 2 to the power of n into u of minus n minus 1. Right? But here there is a z to the power of 19 is there. Z to the power of 19 means which is replace n by n plus 19. So replace n by n plus 19. So minus 2 to the power of n plus 19 u of replace n by n plus 19. So minus of n plus 19. So we are writing minus of n plus 19 minus 1. And what we are going to get? Minus 2 to the power of n plus 19 into u of minus n minus 19 minus 1. Same as it is, right? So minus, where are we can? Now we can here, right? So constant is nothing but here. Basically, constant is there. 2 by 15 into minus 2 to the power of n plus 19 into u of minus n minus 1 minus 19. Same as it is. Now constant is 2 by 35. Take it outside, 2 by 35. And it is equal to minus 3. We are going to get the left side signal. ROC is inward. So what is the value of A? A is nothing but here minus 3. As you can see, A is equal to minus 3. So what we are going to get? Minus of minus 3 onto the power of n u of minus n minus 1. But there is a z to the power of 19 is there. Z to the power of 19 is 3 plus n by 10 plus 19. And what we are going to get? Minus of minus 3 to the power of n plus 19 u of minus of n plus 19 minus 1. So if you simplify, minus of minus 3 to the power of n plus 19 u of minus n minus 19 minus 1. Same as it is. Same as it is with a constant. So therefore we have got this one. So this is what I am trying to tell you. So this is what I am trying to tell you. So this one we have to keep in your plan. So this one always you have to keep in your plan. So therefore you can say that this is the thing that you have. If you remember this formula, everything is very simple and piece of cake. So this formula always you have to keep in your mind. The formulas are a to the power of n into q of n as a transform represent means with an ROC module greater than model. Where minus into a to the power of n into u of minus n minus 1 as z transform z with z minus a with an ROC module less than model. If f of n has z transform f of z, then f of n minus n naught as z transform to the power of minus n naught into f of z, and f of n plus n naught as z transform to the power of n naught into f of z. So this one always you have to keep in the mind. By using this formula only we have solved this question and we got the solution, which is x of minus 18 is equal to minus 2 by 21 is the correct solution of this question. So now we are going to solve the another question. Read the question here. The z transform x of z of a real and right-sided sequence x of n has exactly two poles, and one of them is that is equal to e to the power of j by 2, and there are two zeros at the origin. If x of 1 is equal to 1, which one of the following is true? Isn't it true? The z transform x of z of a real and right-sided sequence x of n has exactly two poles, and one of them is at a that is equal to the power of j by 2, and there are two zeros at the origin. If x of 1 is equal to 1, so which of the following is true? So basically, suppose there is some signal x of n they are given, which is a real signal and also right-sided sequence. Then if you do the z transform of the x of n, we are going to get x of j. And they are also given that it has exactly two poles. One of them is a thing that is located at z is equal to the power of j by 2. And also there are two more zeros which are present at the origin. And if x of 1 is equal to 1 means, in place of z if you substitute 1, then we are going to get its value is equal to 1. Then what is the, out of this option, which is the true option we need to figure out, means x of z we need to figure out, and also ROC also we need to figure out. For the four options, option D, which is x of z is equal to 2 z square by x square plus 1 into ROC is not greater than 1. So this is the correct solution of this question. So let's solve this numerical. So from the data, we know that two zeros are at origin. So from the data, we know that there are two zeros at the origin. So in the x of z, they have mentioned that there are two zeros which are going to present at the origin. Two poles are there. One pole is at z is equal to the power of j by 2. It is nothing but plus j. So see, there are two poles are there in the x of j, and also they have told that one pole is located as a it is equal to the power of j by 2. So if we expand what we are going to get cos theta plus j sin theta, and it is equal to pi by 2. So we are going to get plus j we are going to get. So the other pole is the complex conjugate. See, always the irrational roots and the complex roots they are going to come in pair. Means a plus ib means the other will be a minus ib. I have already told you. All the complex roots as well as the irrational roots always they are going to come in pair. They are going to come in pair. So therefore, if one is a plus j means the other will be minus j. So the other pole is a complex conjugate pole, which is nothing but z is equal to the power of minus j by 2 is nothing but minus j. A plus id means the other will be a minus id, that's it. So plus j means a minus j. So what are the zeros? The zeros are 0, 0 already they are mentioned, and the poles are plus j and minus j. So then what is x of j? From this what we know, x of j is nothing but z minus 0 into z minus 0. Let me assume some constant k by z plus j into z minus j. So this is what we can write from the given data. So x of z is equal to k into z square by z plus j into z minus j. The middle roots are called zeros and the other roots are called poles. So we simplify what we are going to get k z square by a plus b into a minus b, a square minus b square. So z square minus of j whole square is equal to z square plus 1 we are going to get. And also they are given that x of 1 is equal to 1 means in place of z if we substitute 1, we are going to get its value is equal to 1. They are mentioned. So 1 is equal to k into 1 square by 1 square plus 1. This is nothing but 1 is equal to k by 2. So k is equal to we are going to get. So if we substitute here, we are going to get the value of k also. So x of z is equal to 2 into z square by z square plus 1. Z square plus 1. So now basically, now we got the x of z, but now we need to get what is the ROC also we need to figure out. So if you see, this is z plane, so this is the real part of z and this is the imaginary part of z. So now let me plot the poles as well as the zeros. The zeros are 0, 0 and the poles are the plus j and minus j. So you can say the zeros are 0, 0 and the poles are plus j and minus j means it's a unit circle. Plus j and minus j means they are going to lie on the unit circle. The amount of the poles. So let me draw the amount of the poles. What is the amount of the poles? The amount of the poles are nothing but the amount of the poles is nothing but 1. 1 comma 1. Or you can say 1 comma 1 means they are going to lie on the unit circle. As also they have mentioned what they have mentioned. They have mentioned that the x of n is a right-sided signal. As it's a right-sided signal, the arrows is always outward of a circle. So we should not include the poles. The arrows is outward of this unit circle. So mod z greater than mod 1. So as x of n is a right-sided sequence and the poles are that is equal to plus or minus j. So its ROC is mod z greater than. I already told you the ROC is never going to include the poles. The ROC will never going to include the poles. So as the signal is right-sided, ROC is only outward of a circle. It is mod z greater than 1, which is nothing but the poles are going to be on the unit circle. So further I can say what is the x of z? X of z is equal to 2 z square 2 into z square plus 1 with an ROC mod z greater than 1. So this is what we can say from the given equation. So finally the z branch of the given signal is equal to 2 into z square plus 1 with an ROC mod z greater than 1. So this is the correct solution of this question. We are going to discuss the other question. See the question here. The impulse response h of n of a linear time invariant system is real. The transfer function h of z of the system has only one pole and it is at z is equal to 4 by 3. The zeros of h of z are non-real and located at mod z is equal to 4 by 3. The system is. The impulse response h of n of a linear time invariant system is real. The transfer function h of z of the system has only one pole and it is at z is equal to 4 by 3. And the zeros of the h of z are non-real and located at the mod z is equal to 4 by 3. The system is. So if you see clearly, for a linear time invariant system, the impulse response h of n is real. And the transfer function is the z transform of the h of n. We have got h of z. And also they have mentioned that it has only one pole, which is at z is equal to 4 by 3. And the zeros of the h of z are non-real. Non-real means they are not purely real, means they are complex in nature. And they are going to negate that mod z is equal to 4 by 3. So at a radius of 4 by 3, they are going to get present and they are not real. Not real means non-real means real means purely real number. Non-real means they are complex numbers. They are going to become complex numbers. So the zeros are nothing but they are the complex numbers which are going to present at a radius of 4 by 3. Then we have to comment on the nature of the system. We have to comment on the nature of the system. So they have given option is stable, then causal, option B unstable and anti-causal, and option C unstable and causal, and option D stable and anti-causal. So the four options, option D is a stable and anti-causal is the correct solution of this question. So let's solve this numerical. So basically what they are given, basically for impulse response they are given that the pole is, there is only one pole. There is only one pole. This is a real pole. If there is only one real pole which is present at mod z is equal to 4 by 3. So basically if you see what they have mentioned, there is only, we can say, there is only one pole which is present at, there is only one pole which is present at z is equal to 4 by 3. So only one pole is going to present at the z is equal to 4 by 3. This pole is equal to plus 4 by 3. And what are the zeros? They are not real. Non-real means complex numbers. They are going to present at a radius of 4 by 3. So I am going to take zeros are 4 by 3 into the power of plus or minus j eta. Because always I want to tell you the complex roots are going to come in the pair. They are going to come in the pair. One a plus ib means the other will be a minus ib. So here plus or minus j theta. So therefore we can say plus or minus theta means plus or minus j theta means one will be a plus ib means the other will be a minus ib. So complex conjugate zeros are going to be present. Always the complex roots are going to come in the pair as well as the irrational roots are also they are going to come in the pair. So now what is h of z? Zeros by poles. So z minus here z minus 4 by 3 into e to the power of plus j theta, then z minus 4 by 3 into e to the power of minus j theta, that we are going to get here by z minus 4 by 3. So this is the numerator roots are called as the zeros and the denominator roots are called as the poles here, right? Then as you see clearly what you can mention, what is the highest power we are going to get here? Z square. And what is the highest power of z we are going to get? 1. Listen carefully. Here the highest power of z is z square. If the highest power of z is 1, so numerator always is greater than the denominator order, or numerator degree is greater than denominator degree. Then what is the thing that we are going to get? Suppose let me assume this is z cube, this is z cube, then z square. Then by z, what we are going to get here? Z square plus z we are going to get. So what is the meaning of this one? I have already told you what is the meaning of z transform. Is sigma n is equal to minus infinity plus infinity x of n into z to the power of minus n. Suppose if you substitute n is equal to minus 1, then what we are going to get? X of 1 into z to the power of 1. If you substitute n is equal to minus 2, then what we are going to get? X of a minus 1 here into z to the power of plus 2. So what is the thing here? What is the meaning? The signal is going to present only from minus 2 and minus 1, means at n is equal to minus 2 and at n is equal to minus 1, we are going to get the values. At n values, only these things we are going to get. Yes, we can say this is a left side signal because for right side its value is equal to 0. So similarly here, as the numerator degree is greater than the denominator degree, what is the meaning of this one? This signal will have the right part is equal to 0, means f of n is equal to 0, f of n is equal to 0 for n greater than 0. So therefore we can say this is a left side signal. So we can say this is an anti-causal signal also we can say. So it is an anti-causal, means h of t is equal to 0 for t greater than 0. So it is a left side signal. So its ROC is involved, which is not z less than 4 by 3. So if you see clearly, see h of n is nothing but for h of n only we are going to do the z transform, right? So for h of n only we have did the z transform and we got h of z. So from h of z, we have got the values of z, positive values only we are going to get. Positive values only we are going to get. So what is the meaning of this one? H of n equal to 0 for n greater than 0. So what is the meaning of this one? This is called as the left sided signal. So if this is a left sided signal, then what is the meaning of this one? The ROC is inward. And I already told you what is the meaning of causal signal. Causal signal means if h of n is equal to 0 for n less than 0, then we say it is a causal signal, right? What is the opposite of this one? H of n is equal to 0 for n greater than 0, then we say it is an anti-causal signal. In this case, what we can say now? This is nothing but anti-causal signal. That is the reason opposite of that one. So if h of n is equal to 0, if h of n is equal to 0 for n less than 0, we say it's a causal signal. What is the opposite of this one? If h of n is equal to 0 for n greater than 0, we say it is an anti-causal signal. Same thing we are going to get. So it is a left side signal or anti-causal signal. As it's left side signal, so the ROC is inward. So the ROC is inward. So as it's anti-causal signal, so therefore we can say h of t is equal to 0 for t less than 0. So it's a left side signal. So its ROC is inward, which is inside the pole. The pole is nothing but 4 by 3. So inside the pole is nothing but modulate less than 4 by 3. See, the ROC can include the zeros. It doesn't matter, but it should not include the poles, because if it was up to the zeros, anyway we are going to get 0. It's a finite value. But if it's up to the poles, we are going to get infinite. But it's not a finite value. So the ROC is never going to include the poles, or it can include the zeros. So therefore the modulate less than 4 by 3 is the ROC. So, and as ROC is going to include the unit circle. See, 4 by 3 is nothing but it's a greater than 1. So the ROC is going to include the unit circle, because modulate less than 4 by 3 is the ROC is going to include the unit circle. So therefore, whenever the ROC is going to include the unit circle, which we can say that the descriptive Fourier transform is going to get exist, means the signal is absolutely integer, means the system is said to be stable. So therefore we can say, so the system is said to be stable as well as the anti-causal. So therefore finally I can say the given system is said to be stable as well as the anti-causal. Listen carefully. As the ROC is going to include the unit circle, what is the meaning of this one? The descriptive Fourier transform with the given signal is going to get exist. Means h of n is absolutely summable. H of n is absolutely summable. If h of n is absolutely summable, what we can say, the given system is also said to be stable. Listen carefully. Whenever the ROC is going to include the unit circle, it indicates that the descriptive Fourier transform is going to exist for the given signal. Descriptive Fourier transform is going to exist only if the signal is absolutely summable. If the signal is absolutely summable, we also know the system is said to be stable. So therefore we can say finally the given system is said to be stable as well as the anti-causal. So let me give you some more concepts. For x of n, what is Z transform formula? X of n is equal to sigma n is equal to minus 70% x of n into the power of minus n. So what is the discrete time Fourier transform of x of n? Where z is the represent by e to the power of j omega. That's it. X of e to the power of j omega. Some books they take which has x of omega also. Sigma n is equal to massive to percent x of n into e to the power of minus j n omega. And only in z transform represent by e to the power of j omega when we are going to get the discrete time Fourier transform. And only told you whenever a given signal is absolutely summable, what we can say, the discrete time Fourier transform is going to get exist. Whenever the given signal is absolutely summable, the discrete time Fourier transform is going to get exist. It is depend for each and every value omega. If h of n is absolutely summable, what is the meaning of this one? If h of n is absolutely summable, then only the discrete time Fourier transform of the given signal is going to get exist. Then ROC of the h of n is going to include the unit circle. If h of n is absolutely summable, means the discrete time Fourier transform of h of n is well defined, and the LT system is said to be stable, and the ROC of the h of n is going to include the unit circle. So therefore we can say, as you can see clearly, I am going to draw in the jet plane. In jet plane, what I can do, I can tell you the location of the zeros. The zero location is here. This z is equal to 4 by 3 into the power of j theta, and the z is equal to minus is 4 by 3 into the power of minus j theta. So this is plus angle theta and this is minus angle theta. I already told you all the complex groups are going to come in a pair. And this is a 4 by 3. This is a 4 by 3. All are going to lie on a circle of radius 4 by 3 only. They are going to lie in a circle of radius 4 by 3. So the ROC is always inward. So as the ROC is inward now, because you can say basically the ROC is inward. The ROC is basically inward. So therefore, what I can say simply that so therefore you can say simply so what I can say, the ROC is going to become inward. Because I wanted to this left side segment. That is the reason the ROC is inward, right? So now that can say 4 by 3. So therefore finally the given system is said to be stable as well as anticausal. And also we can say this is the nature of the ROC. The module is the 4 by 3. So this is the jet plane. So finally I want to tell you only one important part. If a given signal is absolutely summable, then it indicates that the discrete time Fourier transform is going to exist for that signal. So and also we can say the given signal is said to be energy signal, or we can say the given system is said to be absolutely stable because the impulse response is absolutely summable. The given system is also said to be stable, and the ROC of the h of z the always include the unit circle, because it is equal to 1 into e to the power of j omega means it should include the unit circle. Then only the discrete time Fourier transform is going to exist. So this is the correct solution of this question. So now we are going to solve the another question. See the question here. The pole zero plot of the transfer function HA of S of a linear time invariant system in S plane is shown in the figure. The corresponding impulse response HA of T is sampled at 2 Hz to give the discrete time impulse response sequence H of K. If the right half of the S plane is mapped into the outside of the unit circle, then which one of the following shows the equivalent pole zero plot of the H of Z in the Z plane? The concentric circles are the module is equal to 1 by A and module is equal to 1. Listen carefully. This is a very important question as well as a tricky question. So I request you to answer this question in a very detailed manner. The pole zero plot of the transfer function HA of S. The pole zero plot of the transfer function HA of S of a linear time invariant system in the S plane is shown in the figure. So basically, they are given this one is nothing but the pole zero plot of the transfer function H of S of a linear time invariant system in the S plane. Means, basically, we can say that in the continuous time domain, we have got the Laplace transform of H of N, which is H of S, and this is the pole zero plot. The zeros are nothing but plus j by 2 minus j by 2, and here minus 2. These are the zeros. Zeros are plus j by 2 minus j by 2. And minus 2. The poles are minus 2 plus j5 minus 2 minus j5 and 0. So we have basically 3 poles and 3 zeros. The poles are 0, minus 2 plus j5 minus j5 minus 2 minus j5. The zeros are minus 2 plus j by 2 and minus j by 2. So we have 3 poles and 3 zeros in the S plane. The corresponding impulse response HA of T is sampled at 2 Hz. So basically, for H of S, if we do the Laplace inverse, then we are going to get the H of T. So this signal, now we are going to sample at 2 Hz. Sample means we are going to convert the analog signal to the discrete time signal. The signal is now sampling at 2 Hz in order to get this impulse response is h of e. So if you see clearly, see h of t is there, right? H of t is there. For this one, I have did the Laplace transform. Then I got h of s in the time domain, right? So this is the pole zero plot. So this is the pole zero plot of the h of s. Okay. Now what I will do, I will sample the signal. I will sample the signal. A sampling frequency of 2 Hz. Then I have converted into a discrete time signal, which is h of n. Basically, I did the sampling by 2 Hz. Then I got the discrete impulse response, which is h of n. If the right half of the S-plane is mapped into the outside of the unit circle, I already told you the right half of the S-plane is mapped outside the unit circle, and the left half of the S-plane is mapped inside the unit circle, and the imaginary part of the S-plane is going to map on the unit circle. This is what I already told you. The left side of the S-plane is mapped inside the unit circle, and the imaginary part of the S-plane is mapped on the unit circle, and the right side of the S-plane is mapped outside the unit circle. This is what I already told you now. Which one of the following shows the equivalent pole zero plot of the h of z in a jet plane? So basically, these are the pole zero of in the S plane. So now I want to map this. I want to map this to the discrete time, to the h of z. See, this is a pole zero of h of s, right? These are the pole zero of h of s. But now I want to convert this to pole zero of the h of z. So listen carefully. This is h of n, right? Now what is the jet transform of this one? Jet transform is nothing but h of z I am going to assume. So now what is the pole zero plot of these things? So for these things, now I am going to convert these things into jet plane. So what is the pole zero? Means for this one, what is the pole zero plot I want to figure out? Pole zero plot I want to figure out in the jet plane. So listen carefully. H of t is the time domain impulse response. I have the Laplace transform and I got h of s. For this, the poles and zeros they are given in this S plane. Now this impulse response I have sampled with the frequency of 2 Hz. Then I have converted this to discrete impulse response of h of t. So if I do the jet transform, then I got h of z. So now what is the pole zero plot of this h of z I want to figure out? Of this h of z means what is the corresponding pole zero plot of these poles and zeros I want to figure out in the jet plane that I want to figure out. So for the 4 options, option B is the correct solution of this question. So let's solve this numerical. And also I mentioned that these concentric circles are nothing but the inner circle has a radius of 1 by e and the outer circle has a radius of. So the option B is the correct solution of this question. So let's solve this numerical. So we can see clearly in the S plane. I want to do after h of t. So for this one, the impulse, the pole zero plot in the S plane, which is up in the pole is here 0, the other pole is -2 plus j pi, -2 minus j pi, and the zeros are plus j by 2, minus j by 2, -2, as you can see clearly here. So let me tell you some important formula. Suppose x of t is there. What is the Laplace transform? X of t is equal to integration of t is equal to minus into plus into x of t in the power of minus s t into dt. Suppose what I will do, I will replace so what is the meaning of this one? I am converting and converting that is the reason I have replaced t by n. So basically with the help of sampling and I am converting the replace t by n plus. So here also replace t by n plus. So n plus. Then the t by n plus, here also t by n plus. So this one I am going to assume it is nothing but x of n I am going to assume. If x of n is there, what is jet transform? You know, if x of n is there, what is jet transform? Is it is for sigma n is equal to minus n to plus into x of n into z to the power of minus n, z to the power of minus n, right? Minus n. Now, if you compare, by comparing these two things, what I can say, z is nothing but, by comparing what I can say, z is here, minus n is there, minus n, minus n. E to the power of s into ts is nothing but j. It is nothing but e to the power of s into ts. Suppose if this ts is equal to 1, then what is going to happen? Suppose if this ts is equal to 1, then what is going to happen? Then z is equal to e to the power of s. this is the convention that we have used in our formula, right? Where I have already told you. See, PS is equal to, if PS is equal to 1, then what we are going to get? We are going to get this. If PS is equal to 1, then we will get this. Just that is equal to the power of S. It is equal to but in our conception, we have assumed PS is equal to 1. Then only we are saying that it is equal to this one is not equal to this one. This one I want to do in our that is the reason we have to use the actual formula. That is called the power of S into PS. So this formula you have to keep in your mind. So by comparing only we can say if the replace P by NPS, then by comparing these two equations, what I can say that is nothing but e to the power of S into PS. By comparing these two things, what I can write like this, right? I can write e to the power of S into PS e to the power of minus n. So this is nothing but e to the power of minus n. It is called e to the power of S into PS. This is the actual value of J. But in our side region, by default we have assumed PS is equal to 1, the sample time is equal to 1. So therefore, then what we are going to get? P is nothing but P is equal to n, we are going to get. It means that only the integer values. N is equal to plus 1, plus 2, plus 3. Like that we are going to get. So therefore, what I am trying to do is very simple. If P is equal to 1, then that is equal to the power of S. If P is not equal to 1, then that is equal to the power of S into PS. So now, what is sampling frequency? Sampling frequency is equal to x, 2 volts. And what is sampling time interval? PS is equal to 1 by fs. This is 1 by 2. Now the given sampling frequency is equal to 2 years. Now I want to find what is the sampling period. It is 1 by fs, which is 1 by 2. Now, what are the zeros in the S plane? So first let me tell you what are the zeros in the S plane. What are the zeros in the S plane which are minus 2 plus or minus j pi by 2. So the zeros are in the S plane which are S is equal to minus 2 plus or minus j pi by 2. So now I want to convert these zeros from S plane to Z plane. So I want to convert these zeros from S plane to Z plane. How? With the help of this conversion. That is equal to the power of S into PS. Now let me take the first zero, this minus 2, and let me see where it is going to end in the Z plane. So this is equal to the power of, this is nothing but minus 2. So minus 2 into PS with 1 by 2. So if we simplify, we are going to the power of minus 1. If the power of minus 1 is nothing but 1 by e. This is a real number. There is no phase angle. So 1 by e into angle 0 degree. Similarly, let's go for another zeros plus or minus j pi by 2 in the S plane. Now we will see how they are going to end in the Z plane. Which is that is equal to the power. This is nothing but plus or minus j pi by 2 into what is Ts of. So if simplify, what you are going to get with the power of plus or minus j pi by 2. So now, this is a in the polar format. What is the magnitude 1? And what is the phase angle plus or minus pi by 2? So now we can say minus 2 in the S plane is now converted to 1 by e at a phase angle of 0 degree. Similarly, plus or minus j pi by 2 in S plane is now converted to 1 at an angle of plus or minus pi by 2. So now let me draw the picture here. So this is 1 by e at an angle of 0 degree. So 1 by e is nothing but this one. This is a pointer 1 by e at an angle of 0 degree. And now the next thing is 1 at an angle of plus or minus pi by 4. So this is the 1 at an angle of plus pi by 4 and this is the 1 at an angle of minus pi by 4. Radius and angle. So this is a 1 point and this is other point. So this is a 0, this is also 0 and this is also 0. Right? This 0, this 0 and this 0. Now, poles in the S plane. What are the poles in the S plane? As you can see clearly, the poles are minus 2 plus j pi, minus 2 minus j pi and 0. These three poles are there. 0, minus 2 j pi, minus 2 plus j pi. These are the three poles. I want to convert these poles from S plane to Z plane with the help of this conversion. That is called the power of S into PS. Now let's go for the S is equal to 0 meter substitute. How we are going to end in the Z plane? That is called the power of S is 0. 0 into 1 by 2 which is nothing but the power of 0 is nothing but 1. So if we try to convert into polar format, we are going to get 1 at an angle of 0 degree. Similarly, that is equal to the power of S into PS. It's nothing but minus 2 plus or minus j pi into 1 by 2. So in simplify, we are going to get the power of minus 1 plus or minus j into pi by 2. So if I try to convert the power of n plus n is nothing but n to the power of m into e to the power of n. So e to the power of minus 1 into e to the power of plus or minus j pi by 2. So now if I take the magnitude is 1 by e and the base angle is plus or minus j pi by 2. So pi by 2. So same thing I will take, that is equal to e to the power of minus 1 into e to the power of plus or minus j pi by 2 is nothing but 1 by e into base angle of plus or minus pi by 2. So now basically we have converted all the zeros from S plane to Z plane and all the poles from S plane to Z plane. So now I am going to plot it. So what is the first zero? 1 by e here at the angle of 0 degree. This is the first zero. Second zero is nothing but 1 at an angle of plus or minus pi by 4. So this is the 1 at an angle of plus pi by 4, 1 at an angle of minus pi by 4. Now next pole is nothing but, now I am going to plot the poles. First pole is 1 at an angle of 0 degree. So this is a 1 at an angle of 0 degree. Now next thing is the other two are 1 by e plus pi by 2. So this is a 1 by e plus pi by 2 is here, plus 1 by e plus pi by 2, again 1 by e minus pi by 2. So this is the circle of radius 1 by e, this circle of radius 1. So this circle of radius 1 with this circle of radius 1 by e. So you can see the poles are 1 by e at an angle of plus pi by 2, 1 by e at an angle of minus pi by 2, and this is 1 at an angle of 0 degree. The zeros are 1 by e at an angle of 0 degree, here 1 at an angle of plus pi by 4, 1 at an angle of minus pi by 4. So now I have plotted all the zeros as well as poles for the Z plane from S plane to Z plane. So always remember Z is equal to the power of S into PS. PS is equal to what that we have already assumed in the standard procedure by default. But here PS is not equal to 1. So in that case you have to use the Z is equal to the power of PS, where PS is the sampling frequency. By the sampling frequency only we are going to convert the analog signal into discrete signal. So inner circle is having a radius now Z is equal to 1 by e, and outer circle is having a radius now Z is equal to 1. So I have mapped all the zeros and poles from S plane to Z plane in a successful manner. So basically I have mapped all the zeros and poles from S plane to Z plane by using the convention Z is equal to the power of PS. PS is equal to 1 by default if they are not mentioned. If they are not mentioned means PS is not equal to 1. Suppose if they are not mentioned means PS is equal to 1. If they are mentioned means PS is not equal to 1 in that case. If they are mentioned means, if they are not mentioned means PS is equal to 1. If they are not mentioned means, suppose if they are not mentioned means PS is equal to 1. Suppose if they are mentioned means PS is not equal to 1. Not mentioned means PS is equal to 1. Mentioned means PS is not equal to 1. So this point you have to keep in your mind. So you can see clearly only option B is we are going to get here 4, and also here 4. Zeros are here 0, here 0, here 0. So whereas in the remaining thing they are given wrong. Here is wrong. Here is okay. Here is wrong. Here it should be, here it should be. So remaining things are wrong, and this one is the correct solution of this question. We are going to solve another question. See the question here. The autocorrelation of a sinusoid. So S of t is equal to A into sin omega t. So for this function we have to find what is the autocorrelation. So S of t is a sinusoidal signal which is having a amplitude of A, frequency of A, and a frequency of omega. For this sinusoidal signal we have to find what is the autocorrelation function. We need to figure out. So there are 4 options. Option C, A square by 2 into cos omega tau is the correct solution of this question. So let's solve this numerical. So basically in the question what they are given, x of t is a sin omega t. So what is omega? Omega is equal to 2 pi by t. So omega is nothing but angular frequency in the radians per second, and t is a time period. So fundamental time period in the seconds. Then what is omega t? Omega t is equal to 2 pi, as you can see clearly from this expression. So for a periodic signal, because sin omega t is a periodic signal, for periodic signal, what is the autocorrelation? Suppose f of t and g of t are the periodic signals, and what is the autocorrelation function? We can say the cross correlation, because if f and g are the different functions, if whenever between the 2 different functions if we are going to do, that is called as autocorrelation, cross correlation. Between the same functions if we are doing means it is a autocorrelation. Listen carefully. If f and g are different means it is nothing but cross correlation, and if f and g are same means it is nothing but autocorrelation. So now you can see the cross correlation is nothing but it is equal to 1 by t integration over the t f of t into g of t minus tau into dt. So this formula you have to keep in your mind. Suppose if f and g are same, in place of g substitute f, then what we are going to get the same thing. In place of g I substitute f as it. So R f of tau is nothing but 1 by 2 integration of t, f of t into f of t minus tau into dt. That's it. It's a very, very simple thing, right? So what I'm trying to tell you is very simple. This formula you have to remember. The cross correlation means between the different functions, if you do means it is a cross correlation. Auto correlation means between the same functions means it is a auto correlation. So now, here basically in this question they're asking auto correlation means between the same function x only. So R x of tau is nothing but 1 by t integration of the t. This is a clear signal. So this is the expression for the clear signal. But for any signals, this 1 by t and integration of the t, this will be never present only. These two things are going to be present. So this one you have to keep in your mind here. So this is the expression of the cross correlation and the auto correlation for periodic signals. So now what do you have to do? Very simple. Listen carefully. F of t is nothing but here x of t is a sin omega t, and f of t minus tau is replace t by t minus tau. Then what you are going to get? A sin omega t into a sin of omega of t minus tau into dt. So now a is nothing but a square. It's a constant, take it outside the integration. So a square by t integration of the t sin omega t into take omega inside, then what you are going to get? Sin of omega t minus omega tau into dt. So now if you see clearly here, t is a variable whereas the tau is a fixed. Here tau is a fixed value and t is a variable. Because we are doing with respect to t means t is a variable and tau is a fixed, as you can see clearly from this one, because we are doing with respect to t means t is a variable and tau is a fixed here. So now here sin a into sin b. What is sin a into sin b? You know the formula, right? Sin a into sin b. Well, see, listen carefully. What is sin a into sin b? See, cos of a minus b plus cos of a plus b. What we are going to get? Simply 2 cos a cos b we are going to get. Suppose if you do cos of a minus b minus of cos of a plus b, then what we are going to get? Here minus means the plus will get plus plus minus. So we are going to get finally 2 sin a sin b you are going to get. 2 sin a sin b, right? And what is sin a into sin b? 1 by 2 terms of cos a minus b minus cos of a plus b. Same thing here. Sin a into sin b is nothing but 1 by 2 into cos of a minus b minus cos of a plus b. So 1 by 2 cos of a minus b, omega t minus omega 2 plus omega 2 minus of cos of a plus b. If you do the a plus b, what we are going to get? 2 omega t minus omega 2. It is a is equal to omega t, b is equal to omega t minus omega 2. By using that formula, we have got this expression. Now 2 is a constant, take it out to the integration, s over 2t, integration over the t. Now take dt inside, and what you are going to get? Integration over the t, cos omega tau into dt minus integration of time period, cos 2 omega t minus omega tau into dt. I have substituted, basically I have separable integration, I have dt. So s over 2t, as we are doing with respect to dt, as we are doing with respect to t, so tau is a fixed value, so take it out to the integration. So cos omega tau into integration of 1 is nothing but t, subs the limit 0 to capital T minus. See, as you can see clearly, t is a variable but tau is a fixed. I have already told you, integration of cos n omega t minus 5 plus or minus 5 over a complete time period is nothing but it's always equal to 0. So I have already told you this one. Basically, I have already told you integration over the one time period cos of n omega t minus plus or minus 5. This is always equal to 0. It's always equal to 0. But let me prove here. Let me prove for you. So therefore, you can see clearly that what is sin derivative is cos. So integration of sin is nothing but integration of cos is nothing but sin. So sin 2 omega t minus omega 2 by, as you are doing with respect to t, so here it will become 2 omega you are going to get here. So sin derivative is cos. Sin derivative is cos. So integration of cos is nothing but sin. So sin 2 omega t minus omega tau by, as we are doing with respect to t, so tau is a fixed value, so we are going to get by 2 omega you are going to get. Subs the limits from small t is equal to 0 to small t is equal to capital T. If you substitute t minus 0 is equal to t, we are going to get, so a square 2t into t into cos omega tau minus, then 1 by 2 omega into upper limit minus lower limit, in case of small t substitute t, then 0. Then what we are going to get? Sin of 2 omega t minus omega tau minus sin of 0 minus omega tau minus omega tau we are going to get. So now, a square 2t into same as it is minus 1 by 2 omega. As I have already told you, omega t is nothing but 2 pi. So 2.2 is equal to 4 pi. Sine of 4 pi minus omega 2 minus of. So sine of minus theta is equal to plus sine of minus theta is equal to minus sine theta. Sine of minus theta is equal to minus sine theta. So minus come outside. Minus will become positive. So plus sine omega tau. You know, sine 4 pi minus theta. What is sine 4 pi minus theta? It is in the fourth quadrant. In the fourth quadrant, sine 4 pi will become 360. So 2 pi is 360. Then what is 4 pi? 720. So when your sine will become sine only. It will remain same as it is. Sine will remain sine only. But here, in the fourth quadrant, sine is negative. So you have to keep here negative. So minus sine omega tau. That plus sine omega tau. So they are going to get cancelled. And finally, you are going to get this value is equal to 0. Only this thing is going to get present. So s square by 2t into t cos omega tau. So t cancels. We are going to get finally the auto correlation is equal to s square by 2 into cos omega tau. So I have put also this formula you have to remember. This is a formula for the cross correlation of two different periodic signals and is a auto correlation for the same periodic signals. If you remember one thing, the other thing is very simple in terms of the substitute. Then we have substituted it, we have simplified it. The small t is a variable and tau is a fixed value. Whereas in that we have simplified it is s square by 2 into cos omega tau. Just now we have proved also. So, and also I already told you, see, whenever 90 is there, whenever 90 and 270 is there, then sine will become cos and cos will become sine, right? Tan will become cot and cot will become tan. Right? Then sec will become cosec, cosec will become sec. I already told you for 90 and 270. Suppose if there is a 180 and 360 is there, in terms of 180 and 360, sine will remain sine, cos will remain cos. This one I already told you. The tan will remain tan. And similarly, cot will remain cot. So it may be cot will remain cot only. And similarly, sec will remain sec only. And the cosec will remain cosec only. So this one I already told you so many number of times. As 2 into 360 is nothing but 720. So it is on in terms of 360. So therefore, sine will remain sine only. But in the fourth quadrant, sine is negative. So the sine is negative. So the sine itself is negative. So you have to keep here minus here. Right? This is minus. We are going to get cancelled and we are going to get finally a square by 2 into cos omega tau. So this is what we are going to get finally. So therefore, this is the correct solution of this question, and you have to remember which is either x of t is a sin omega t or a cos omega t. The order of correlation is always same. This a square by 2 into cos omega tau. So this one also I already told. Whether x of t is a sin omega t or a cos omega t, the order of correlation is always same. It is nothing but a square by 2 into cos omega tau. So this is a very important thing. Always you have to keep in your mind. Whether x of t is a sin omega t or a cos omega t, the order of correlation is always same. It is nothing but a square by 2 into cos omega tau. So this formula you have to always keep in your mind. In examinations they are going to ask this one. So if you remember the formula, it is very easy to solve this type of question. So therefore, whether a given signal is a sin omega t or a cos omega t, the order of correlation is always same. It is a square by 2 into cos omega tau. So remember, if x of t is equal to a into sin omega t or a into cos omega t, then the order of correlation is always equal to a square by 2 into cos omega tau. So let me give you one important formula. Let me write the formula for a periodic signals. What is the cross correlation for a periodic signals? For two different periodic signals, the cross correlation is nothing but 1 by t integration over the t f of t into g of p minus tau into dt. So this one you have to keep it in mind. Auto correlation is in case of g substitute f, that's it. The remaining thing is same. 1 by t f of t into f of t minus tau into dt. F t is a variable, and tau is a fixed value. So this formula you have to keep in your mind, right? Suppose if they are different functions, then you can use this formula and have to solve that one. Okay? So this is the correct solution of this question. So let's solve the other question. See the question here. Consider the discrete system. A of n is equal to a1 into x of n minus 1 plus a2 into x of n plus a3 into x of n plus 1. The system is, so basically we are given some discrete time system, the input output relation. A of n is equal to a1 into x of n minus 1 plus a2 into x of n plus a3 into x of n plus 1. So what is the system? Option A linear causal, option B non-linear causal, Option C, linear non-causal, and option D, non-linear non-causal. So basically in this question we're asking only about two properties. Whether the system is linear or not, whether the system is causal or not, we need to figure out. So the four options, option C is the correct solution of this question. So let's solve this numerical, which is linear as well as non-causal. So let's solve this numerical. So as you can see clearly, what is the input output relation of the given system? Y of n is equal to a1 into x of n minus 1 plus a2 into x of n plus a3 into x of n plus 1. The given system is said to be linear because there are no non-linear operators like square, cube, 1 by 2. There are no fractions like that. So therefore we can say, as the equation does not have any non-linear term, so it is satisfied both the L2 as well as homogeneity. Hence we can say it is a linear system. As you can see clearly, there is nothing like non-linear operators like exponential, like arc, like logarithm. These things are not there. These things are not there. So by default, we can say the given system is said to be a linear system. So therefore, we can say as the equation doesn't have any non-linear term like exponentials, like powers, like logarithms, like squares, cubes, all these things are not there. So therefore, it is going to satisfy both the L2 property as well as the homogeneity property. And we can say so superposition as well as a homogeneity property. So therefore, we can say the given system is said to be linear system. Now let's go for checking out the causality. In place of n, I will substitute 0. Then y of 0 is for a1 into x of minus 1 plus a2 into x of 0 plus a3 into x of 1. As you can see, at t is equal to 0, it is depending on t is equal to 1. Means the present output is going to depend upon the future values of the input. So the given system is said to be non-causal. At n is equal to 0, the output is going to depend on the future values of the input at n is equal to 1. So we can say the given system is said to be non-causal. So what's the meaning of causal? If the present values of the output is independent of the future values of the input, then we can say the given system is said to be causal. But in this case, as the present value of the output is going to depend upon the future values of the input, so therefore we can say the given system is said to be non-causal. So therefore we can say either the system is nothing but it is a linear as well as the non-causal. So this is the correct solution of this question. So let's solve the other question. See the question here. The convolution of the two sequences shown in the figure is the sequence. So basically, if you see clearly, they are given two signals, discrete time signals x1 of n and x2 of n, and they are asking what is the combination of these two things we need to figure out. Combination of these two things we need to figure out. So if you see clearly, this is at 0 its value is 2, and at 1 its value is 1, and at 2 its value is minus 2. At 0 its value is 0, at 1 its value is 1, at 2 its value is minus 2. So between these two signals, we have to tell what is the convolution. So out of all these options, all options are wrong. So now we'll discuss the exact solution of this question. So basically, what is x1 of n? I've already told you 2, 1, minus 2, right? And x2 of n is nothing but 0, 1, minus 2. The arrow indicates that from this is the value at origin. This is the value at origin. So right side means at n is equal to 1, 2, 3, at left side means at value n is equal to minus 2 goes on. So arrow indicates that this is the value at n is equal to 0. So x1 of n we are going to get 2, 1, minus 2, and x2 of n is nothing but 0, 1, minus 2. So I have already told you the convolution we can do in two methods, one is the Taylor method and the other is the conventional method. Now let's do each and every method in a detailed manner. Let's go for the Taylor method. Shortcut. x1 of n, convolution of x2 of n. Whether you can take x1 of here or here, or x2 of n here or here, you can take here because the convolution is going to satisfy the commutative property. So let me take here x1 of n this side and x2 of n this side. So this is nothing but 2, 1, minus 2. So 2, 1, minus 2. Here, the elements in x1 of n are 2, minus 2. Then comes in the elements in x2 of n are 0, 1, minus 2, 0, minus 2. So do the multiplication. 2 into 0 is 0, 2 into 1 is 2, 2 into minus 2 is minus 4, 1 into 0 is 0, 1 into 1 is 1, 1 into minus 2 is minus 4, minus 2 into 0 is 0, minus 2 into 1 is minus 2, minus 2 into minus 2 is plus 4. So now take the lines like this. Only one element, then two elements, then two elements, three elements, then two elements, and one element. So we do clear addition of all the elements which are all the numbers which are present in this line. Then 0 is 0. 0 plus 2 is nothing but 2. 0 plus 1 plus minus 4 is nothing but minus 3. Minus 2 plus minus 2 is nothing but minus 4. Then 4. So this is the numbers that we are going to get here. So this is a sequence of numbers. And the first thing is nothing but 0. So this is the arrow that we are going to get here. This is the arrow that we are going to get here. So this is the arrow we are going to get. So this is the sequence of numbers in the resultant combination. Always you will take the numbers from up to down. From up to down only you have to take the numbers. And this direction you have to take the numbers and you have to fill it in this order. This order you have to fill it here. Right? And I already told, see, this is basically starting from n is equal to 0. And this is starting at ending at n is equal to 2. Right? This is starting at n is equal to 0 and ending at n is equal to 2. The resultant signal is starting point is nothing but summation of the starting point 0 plus 0 is nothing but 0. And the resultant signal final point is nothing but the summation of the final points here 3 and here 2. 2 plus 2 is equal to 4. So you can see clearly here. So what is the starting point? The starting point is equal to 0. And this is 1. N is equal to 1. N is equal to 2. N is equal to 4. N is equal to 4. So you can see clearly. It is starting at n is equal to 0 and ending at n is equal to 4. So the starting point is nothing but summation of the individual starting points plus, and the ending point is nothing but the summation of the individual ending points. So if you are doing a convolution, the starting point is nothing but the summation of the individual starting points, only the points but not the values, only the starting point. Similarly, the ending point is nothing but summation of the ending points. And also I already told you, which is one important point. Then what is the resultant convolution is nothing but, suppose let me assume this is a phi of n. So sigma of phi of n is nothing but sigma of phi of n is equal to sigma of x1 of n into sigma of x2 of n. This I already told you. How is sigma of x1 of n? 2 plus 1 is 3. 3 minus 2 is equal to plus 1. So this one is plus 1 into. What is sigma of x2 of n? 0 plus 1 is 1. 1 minus 2 is equal to minus 1. So 1 into minus 1 is equal to minus 1. If you do all the addition of elements in y of n, you should get minus 1. 0 plus 2 is nothing but 2. 2 minus 3 is nothing but minus 1. Minus 4 plus 4 we are going to get cancelled. So finally we are going to get minus 1. So you can see this property is also you have to remember. The properties are, whenever you are doing a convolution of two signals, the starting point is nothing but summation of the individual starting points and the final point is nothing but the summation of the final points. And also sigma of phi of n is equal to sigma of x1 of n into sigma of x2 of n. Means we can say the summation of, whenever you are doing a convolution, the summation of resultant signal is equal to the summation of the individual signals and do the product. That's it. So sigma of phi of n is equal to sigma of x1 of n into sigma of x2 of n. So these things you have to keep in your mind. So basically, we have solved this question by the first method and we got the some answer we have got. So this is the correct solution of this question. Now let's go for the other method also. While doing the other method also, we will try to solve this question. Okay. What is x1 of n? In the under method, standard procedure. The standard procedure 2 is delta of n plus 1 is delta of n minus 1 plus minus 2 is delta of n minus 2. What is x2 of n? x2 of n is nothing but 0 is delta of n is 0. 1 is delta of n minus 1 plus minus 2 is delta of n minus 2. Now do the convolution. Just take this sequence and this sequence and do the convolution. Just like the multiplication. So here you are going to get 2 is delta of n minus 1 and then minus 4 into delta of n minus 2. Then do a convolution, what you are going delta of n minus plus delta of n minus 2 and then minus 2 in delta of n minus 3, then minus 2 in delta of n minus 3 plus 4 in delta of n minus 4. So if we simplify, we are going to get finally 2 into delta of n minus 1 minus 3 into n minus 4 plus 1, which is the minus delta of n minus 2. Here minus 2 minus 2 minus 2 minus 4. So minus 4 delta of n minus 3 plus 4 delta of n minus 4. So here 0 comma 2 comma minus 3 comma minus 4 comma plus 4. So this is the resultant signal that we are going to get. So you see clearly by both the methods we got the same thing. So this is the correct solution of this question and this is not there in the options. So therefore all options are wrong. So this is the correct solution of this question. So always remember delta of n minus a convolution of delta of n minus b is equal to delta of n minus of a plus b. By using this formula only you have to get the convolution. So this is the correct solution of this question. So always remember delta of n minus a convolution of delta of n minus b is equal to delta of n minus of a plus b. So this is the correct solution of this question. So now we are going to solve the other question. See the question here. If f of t and f of omega are the Fourier transform pairs, then consider the following statements. So if f of t and f of omega are the Fourier transform pairs, then consider the following statements. So basically f of the Fourier transform is f of omega. So now they are given some statements regarding this one. F of omega exists if f of t has a finite energy. Statement 2, we can say the magnitude of the f of omega is an odd function. Statement 3, f of t minus t transforms to f of omega into e to the power of plus j omega t. And statement 4, f of t into e to the power of j omega naught t transforms to f of omega minus omega naught. So which of the statements are correct? So they are given four statements. Out of this, which is the correct statements, we need to figure out. The statement 1 and statement 4 are the only four correct statements, while the statement 2 and statement 3 are wrong. So now we'll discuss why it is like this in a very detailed manner. So we can see statement 1 and statement 4 are the correct, while the statement 2 and statement 3 are wrong. So now we'll discuss why it is like this. Suppose if you take f of t, okay, if you take f of t and if you take Fourier transform, what you are going to get f of omega is equal to integration of t is equal to mass integration to f of t into e to the power of minus j omega t into d2. This is I've already told. So f of omega is going to get exist when only when f of t is absolutely summable, absolutely integrable. Yes, if f of t is absolutely summable, then only f of omega is going to get exist. What's the meaning of this one? If f of t is absolutely summable, then we can say f of t is an energy signal. It is an energy signal. So f of omega is going to exist only if the f of t is a finite energy signal. So what's the meaning of this one? If f of t is an energy signal, we can say it is an energy signal, then f of t is absolutely summable. Therefore, we can say that f of omega is going to get exist. It's a very different Fourier transform. So therefore, whenever a given signal f of t is absolutely integrable, or we can say it is an energy signal, then by default we can say the Fourier transform is going to get exist. So what is statement 1 they are given? Which is what is statement 1 they are given? F of omega exists if f of t is a finite energy. Yes. Whenever the f of t is an energy signal, finite energy means it is an energy signal, then f of t is absolutely integrable. So therefore, the Fourier transform is going to get exist. So statement 1 is correct. So therefore, the first statement is correct. Whenever a given signal is an energy signal, or we can it is having a finite energy, by default we can say the signal is absolutely integrable, so or absolutely summable. So therefore, we consider Fourier transform is going to get exist. Now, let's go for the statement 2. The statement 1 is correct. Or we can also write like this. Integration of t is equal to minus into x mod of f of dt is less than infinity. The only a Fourier transform of the f of t is going to get exist. I already told you, when f of t is absolutely integrable, the meaning of Fourier transform is going to get exist. What is the meaning of energy? Energy is equal to energy of a given signal is equal to integration of t is equal to minus into x mod of f of t whole square dt. If this is absolutely summable, this phase is also absolutely summable. Okay. If mod of f of t is absolutely summable, then mod of f of t whole square is also absolutely summable, because if you see 2 is a finite value, then 2 square is also finite value. If 3 is a finite value, 3 square is also finite value. So therefore, if f of t is absolutely summable, then mod of f of t whole square is also absolutely summable. So therefore, we can say that it means that energy of the signal should be finite, then only the Fourier transform of the f of t is going to get exist. What is the meaning of this one? Very simple. Suppose if you take a signal f of t, if the given signal f of t is absolutely summable, or absolute summable means we can say the given signal is said to be an energy signal, then by default the Fourier transform is going to get exist. Means if the given signal is an energy signal, then by default the Fourier transform is going to get exist, means it is defined for each and every value of omega. The first statement is correct. Now the second statement. See, I have already told you f of omega is a complex number. There is a real part and the imaginary part. So modulus of f of omega is always an even function, whereas the phase angle of f of omega is always an odd function. But in the statement 2, what they are given, mod of f of omega is an odd function. That is wrong. It is actually an even function. So statement 2 is wrong. So the modulus of the f of omega is always an even function, whereas the phase angle of f of omega is an odd function. So here the statement 2 they are given wrong. So this is a wrong statement. So this is a thing we have discussed. Now let's go for the time shifting property. Time shifting theorem in the case of Fourier transform. If f of t has a Fourier transform f of omega, then f of t minus t has a Fourier transform f of omega into e to the power of minus j omega t. Why is like this? Let us discuss it. For f of t minus capital T, what's the Laplace transform e to the power of minus ts into f of s? I have already told for f of t minus a, what's the Laplace transform e to the power of minus as into f of s, right? So in case of a, I substitute t here. So you are going to e to the power of minus st into f of s. If you want the Fourier transform, replace s by j omega, then what you are going to get this one? E to the power of minus j omega t into f of omega. Same thing, right? Same thing. In case of a, substitute j omega plus 6, then we are going to get the Fourier transform. So therefore, f of t minus a as a Laplace transform e to the power of minus as into f of s. Replace a by capital T, then we are going to get this one. If you want Fourier transform, replace s by j omega, then we are going to get this one. So for f of t minus capital T, the Fourier transform is f of omega into e to the power of minus j omega t. Let's see here what they are given. For f of t minus capital T, the Fourier transform is f of omega into e to the power of, this is minus j omega capital T. But here they are given different. So this is also wrong here. So this is also wrong. Now, let's go for the fourth statement and analyze. Frequency shifting theorem. So, if f of t has a Fourier transform f of omega, then f of t will be the power of plus or minus j omega of t as a Fourier transform f of omega minus plus omega naught. Here plus means here minus, here minus means here plus, opposite side, opposite side. So, here you can see f of t will be the power of plus or minus j omega naught t as a Fourier transform f of omega minus plus omega naught. Here plus means here minus means here plus. So what is that? In here they are given f of t will the power of j omega naught t transforms to f of omega minus omega naught. Here plus means here minus plus, it is the correct only. So this is the correct statement. So this is the correct statement. So therefore only we can say option 1 and option B are the correct statements, whereas option 2 and option 3 are wrong. But if you want the correct statements means, what I can say, if you want this to be correct, it should be n function. If you want this to be correct, then what is the value? It should be f of omega into the power of minus j omega capital T, it should be there. Okay. So this is the correct solution of this question. So now let's solve the another question. See the question here. The Z transform and the ROC of the function. The Z transform and the ROC of the function f of n is equal to the power of n into u of n r. So basically, in this question, what they're asking is very simple. The Z transform and the ROC of the function. So basically, they are given some function f of n is equal to the power of n into u of n. For this function, we have to find what is the Z transform as well as the ROC. We need to figure out. Basically, I already told you for e to the power of n into u of n. What is the Z transform? Z by Z minus a. As it's right side signal, so ROC is always outward. Outward. Outward means outside the circle. This logic play to the one. So if you plot the jet plane, the jet plane, if you plot, then the 0 is nothing but here. This is a 0 and this is a 4. So the 4 is having the radius of a. And I already told you it's outside the outside. That is outside means outside the poles. See the ROC, it may include the zeros or it may not include the zeros, but it should not include the poles. See, the ROC, it can include the zeros or it may not include the zeros. But it should not always include the poles. So therefore we can say not included than not. So here, in this case, ROC is not included in the pole as well as 0. But generally, ROC can include the zeros, it may not include the zeros. But ROC should not always include the, it will never include the poles. So it is always outside the circle, it is a right in the signal. So ROC is logic to the model. So option is a correct solution of this question, because if you simplify, same thing we are going to it is Z by Z minus a. You can logic to the model. But now we will discuss something more about this one also. So here listen carefully. We will discuss something more here. If f of n is equal to the power of n into u of n. So basically I want to find what is the Z transform of f. What is the Z transform basically I want to figure out. And also its ROC also I want to figure out. By using the standard procedure. By using the standard position we are going to discuss here. So for x of n is equal to, suppose if x of n is there, what is Z transform? S of n is equal to sigma n is equal to minus n to plus n x of n into z to the power of minus n. What is x of n is equal to a to the power of n into u of n. So what is the Z transform? S of n is equal to sigma n is equal to minus n to x of n is equal to a to the power of n into u of n into the power of minus n. So as u of n is dependent only from n is equal to 0 to infinity, so its value is equal to 0 from minus n to minus 1. This initially will not become from sigma n is equal to 1 to sigma n is equal to 0 to infinity. And it is going to present on the term n is equal to 0. So sigma n is equal to 0 to present a to the power of n into u to the power of minus n. So a to the power of n into the power of n is equal to a into b to the power of n. So I will take n as a common. So therefore sigma n is equal to 0 to present a into the power of minus 1 to the power of n. So if you do that and substitute the values, what we are going to get from 0, 1 like that, we are going to get x is equal to 1 plus a into the power of minus 1 to the power of 1 plus a into the power of minus 1 whole square. And that we are going to get. Like the infinite number of terms that we are going to get. So this value is going to converge only when there is no geometric series. I already told you the formula in geometric series. This value, the summation is going to converge only when the value of molar is less than 1. This one I already told you that. So therefore we can say that a plus ar square plus ar cube up to infinity, the summation is going to get converged only when the amount of r is less than 1, and it is going to converge to a by n minus r. I have already told this formula. Listen carefully, a plus ar square plus ar cube up to infinity, the summation is going to converge to a by 1 minus r only when the amount of R is less than 1. If you want me to prove this one, let me prove this one. Suppose A plus AR plus AR square. Suppose we have up to A into R to the power of N we have. Suppose R to the power of N minus 1. Let me take here. The summation is equal to A into 1 minus R to the power of here 1 minus R. So here, total number of terms are here 1, here 2. So how many terms are here? Here 2 means, suppose if we take N is equal to 2, and what we are going to get here? 2 minus 1 is nothing. So let me take it N. Suppose for N, let me take it. The first simplification will be, let me take this as N. Then what we are going to get? The 1, 2 means up to N we are going to get. Total number of terms are N plus 1. So N plus 1. Total number of terms are N plus 1. Suppose if you take here A into R to the power of N, then what is going to happen? R to the power of 1, R to the power of 2 is R to the power of N means N terms are here plus 1 more term. So total number of terms are N plus 1. So A into 1 minus R to the power of N plus 1 by 1 minus R. Suppose if this N is equal to infinity, then what is going to happen? This N is equal to infinity and R is less than 1. Then what is going to happen? Isn't very clear. Suppose R is equal to, let me take 1 by 4 and N is equal to infinity. So 1 by 4 all to the power of infinity plus 1. Second, 1 by 4 all to the power of infinity is equal to 0. And this value is going to become 0. So we are going to get A by 1 minus R. So that is the result we are going to get A by 1 minus R. So whenever A plus AR square infinity, it is going to converge to A by 1 minus R only when the amount of the R is less than 1. So by this formula, now we are going to solve this one. So this value is going to converge to A by 1 minus R, where A is equal to 1 and R is equal to A into the power of minus 1. So A by 1 minus A to the power of Z to the power of A into the power of minus 1. And the amount of R is less than 1, which is amount of A into the power of minus 1 less than 1. So if you simplify, what you are going to get 1 by 1 minus A into the power of minus 1. So if you simplify, what you are going to get mod A by mod Z less than 1. Means mod A less than mod Z, or we can write the reverse fashion mod Z greater than mod A. So finally, if you simplify this way, we are going to get Z by Z minus A, in order to say mod Z greater than mod A. So if you can either write in this way or either write in this way. So finally, we are going to get SW is equal to 1 by 1 minus A into the power of minus 1 or Z by Z minus A. You can always say mod Z greater than mod A. So this is the correct solution of this question. But if you remember the formula, you can solve it in a fraction of a second. But in case if you forgot, we can go for this question in order to get the solution. And always remember, rather say, it may include the zeros or it may not include the zeros. It is up to the ROC, but it should not always include it will never include the force, because if you substitute the zeros, anyway you are going to get the 0. Anyway you are going to get the 0. F of Z, you are going to get 0. It's a finite value, but if you substitute force, you are going to include it. So infinity means it is not going to converge. So therefore, ROC means if you substitute those values of Z in F of Z, yeah, you should get a finite value, like 0, like 1, like 2. But if you are doing it infinity means those are, that is not under the ROC. So ROC can include the zeros or it cannot include the zeros, but it will never include the force. This is a very important thing, always should keep in mind. So this is the correct solution of this question. So by this lecture, we have successfully completed some of the civil and system questions which are belong to a Genport transport book in a very detailed manner. And if you like the content of the channel, then please to like, share and subscribe to the channel. And don't forget to press the bell icon button. So whenever we upload a new video, that directly sponsor at all. If any information in our lectures, then please look in the comment section. We will definitely include all those information in the coming lectures. Thank you so much for watching this lecture. Please take care and bye bye.